Good morning to you all, and welcome to our kickoff meeting for the 2019 calendar year of the Technological Advisory Council for the FCC. It's not normal for us to be kicking off the year in June, but through all of the circumstances of government shutdowns and President Bush funeral and all the rest, we find ourselves in that circumstance, but it does work. We have been rechartered, and therefore we're off and running for another 2 years. Those of you who spend your time looking at government documents will be familiar with our FACA requirements, the Federal Advisory Committee Act that says that these organizations are set up for 2-year cycles, and that was accomplished by Michael in May, so we're off and running. We also have had a more rigorous vetting process for all of you, so the fact that you're sitting here says that you proceeded through a rigorous vetting process and that you have been found worthy to be on the TAC, so that's a very good thing. We do have a slate of exciting working group activities this year. They are extensions in this case, partially related to what I've just said. They're extensions of the activities we had last year, but they're very, very big topics with very big implications. I actually had a session yesterday with the liaisons talking about the progress and the value of the work that is accomplished by the TAC to the FCC, and so that's very, very good thing. So we're here and off and running. As is our habit, we'll open walking around the room and having each of you introduce yourselves and the organization that you represent. Mine is an unusual and new one. Entigen Logic is a startup company that is in the artificial intelligence space. Since one of our working groups is focused on artificial intelligence, it seemed like an appropriate representation for me. But most of the individuals around the table, which is part of the FACA Act, represent companies or business entities of one kind or another. There are a few special government employees, and they can recognize themselves as such. They're also affiliated with universities or other organizations, but that's how our operation works. I'm being perhaps a little more elaborate in describing ourselves in our opening because we're in the wonderful circumstance of having 10 new members of our organization for this session, and so we particularly greet them, and we've placed them so that at each end, prime seating, we have the new members of our group. In many cases, the new members, I'm looking at Ted down here, are not totally new since Ted was on the TAC some years ago, and in those years we sat alphabetically, so Rappaport, Roberson, we sat next to each other with some frequency. But for most, this is a new experience, and we're really delighted to have you and looking forward to the contributions that you will be making. And maybe for those who are new, if you could say an extra word, first identify yourselves. I'll not do so, but other than thanking you for being here, but recognize yourselves as a new member of the group, and some expression of your extreme enthusiasm for being here would be appropriate. And we'll take that as a sign to give you more work as the TAC. So that's part of what the interaction is all about there. So with that, let me do the quick once around the table on introductions, and we'll start with our designated federal officer and leader in most respects. Michael, take it away.
Thank you, Dennis. Michael Howe with the Office of Engineering and Technology. As Dennis mentioned, I'm the new DFO for TAC.
Good morning. Karri Kuoppamäki, T-Mobile USA.
Stephen Hayes, Ericsson.
Steve Lanning, Viasat.
Mark Hess with Comcast.
Kevin Luddy, Charter.
Lynn Merrill, representing NTCA.
Mike Naraki with Addis.
Yeah, hi, Satish Dhanasekaran with Keysight Technologies.
Travis Russell from Oracle Communications.
And the three of you didn't express your outstanding enthusiasm for
Very
being here.
excited to be here.
The enthusiasm just leaves me speechless.
Delicious speeches, okay. Well, welcome, Michael, Satish, and Travis. We're delighted to have the three of you here.
Jesse Russell, Inc. Networks.
Art Nichols with Windstream.
Fred Lappin, ARRL.
Marty Cooper, Downer LLC.
John Barnhill with Alianza.
Adam Drobot, Open Tech Works.
Lisa Guest, Cradle Point.
John Chapin, Roberson and Associates, representing the National Spectrum Consortium.
Kevin Sparks, Nokia.
Mark Bayless, Visual Link.
Tom Sawanabori with CTIA. Glad to be here and hopefully contributing to the TAC.
Ted Rappaport with New York University, representing NYU Wireless, a research center supported by government and industry. Happy to be on the TAC. I was on the TAC last about 14 years ago, served for 4 years, so it's gotten a bit bigger, and it seems like it's more work than it was 14 years ago. Happy to be here.
Good morning, Scott Robon, Juniper Networks, one of the 10 expressing appropriate enthusiasm here.
Jeff Forrester with Intel.
Frank Hornick from Motorola Solutions. I'm filling in for Paul Steinberg.
David Young with Verizon.
Dale Hatfield, the University of Colorado at Boulder. It says TCP and not to be confused with Transmission Control Protocol, but rather it's the technology, cybersecurity, and policy program at the University of Colorado.
And you have assured delivery. Eric Berger, FCC.
Julian Happ, FCC, Office of Engineering and Technology.
And Julie, having introduced yourself, do you have a few words to share with the group? He always has.
So good morning. Thank you for coming to help us bring in summer. I think it turns summer at 11:54 this morning.
Yeah, that's true.
So I think that'll be one of our first accomplishments. We can take credit for that. Do you have any people on the phone?
That's right. Yes. Thank you very much. Those on the phone, could you please identify yourself?
Yes. Good morning, Dennis and everyone. This is Brian Daly, AT&T. And even though I've been on the TAC for several years, I still want to express my enthusiasm, so even though I'm not a new member.
Anybody else?
Hi, Dennis and everyone, and Michael. It's Nomi Bergman. I've been on the tech for a while. I'm here representing Advanced. Maybe my representation has changed over the years from Bright House Networks to Advanced, which is all actually still the same company. But I'm thrilled to be here, and I like Brian's comment. I have a lot of enthusiasm for these new groups. Very excited.
Any others on the phone?
Good morning. Hi, everybody. This is Charlie Then from Samsung. I'm happy to be back in the tech group.
Good to have you, Charlie.
Hi, this is Russ Jurek representing Cisco, and I'm sorry I can't be there with you guys today, but very excited about the year we have ahead.
Sounds like that's it.
Okay, welcome those on the phone.
So, again, good morning. And for the veterans, I want to thank you for returning. Just don't tell the newcomers about all the work we make you do. And really privileged both for the folks who stayed and all of the newcomers to the TAC. It's, when you look at all the representation, it's quite impressive. I think of the cross-cut of the communications industry. And we really do listen carefully to all of the advice and your insights. I thought we often do this at the end, but aside from the people you have from the commission here at the table, could the folks from the commission who are in the room just stand up for a minute? So we have representation from across the bureaus and offices. So you don't only have the ear Okay, you can sit down now. That's your. You got to tell them everything. So it really does make a difference. Dennis will probably tell you about. We're always asking for actionable recommendations. Rather, sometimes there's a piece of it where it's just informing us of what's going on. It may not be something that we're going to do in a rulemaking right away, but many of the major projects that we have going at the Commission had their origin in the TAC. So we know that's a lot of work for you, but we're listening, and it really is a valuable contribution for the agency. Thinking about the topics, we last met in March. It was our 20th anniversary. So that the TAC has had a long history of accomplishment, and I'm quite confident we'll continue with that. So the March meeting was the end of the 2018 TAC, and Dennis was alluding to all of the things that were going on since then. May not seem like much, but anybody who thinks it's not will give you the challenge of trying to get something through the Federal Register. So we renewed the charter, went out with a call for renewed membership, went through all of the review and the vetting that has to happen through that. For the topics, when we left off in March, I think the recommendations from several of the groups that there was more work to do on those topics, coupled with the fact that we have a shorter cycle this year, that made a lot of sense. So I won't go into the topics, but as we get into them, I think they're all very much front and center on things that we and others, I think, in government are trying to tackle. So I thank you for your work. We look forward to the presentations. I have to apologize in advance. I can't stay the whole time. I hate to do that, but I got called to another meeting that I'm just going to have to attend. So, but I will get the full rundown. I've already looked at the presentations, and thank you.
And having talked to Julie, he would much rather be here with us than where he is required to go. You can talk to him privately about that. Michael, if you would lead forth on the agenda and the plans for the day.
Yeah, so with the strong leadership from Dennis and Julie, it makes my job much easier, and I try to focus more on all of the administrative processes for the TAC. And for today's meeting, here is the agenda. So we will start out with the antenna working group, and then 5G IoT working group, and we'll break for lunch. When we come back, I'm sure the AI working group will keep us awake, and then we'll close the June tech meeting with exciting updates from UAS working group. With that, maybe we'll just hand it over to Marty and Greg for their presentation.
Thank you very much. We're very pleased to be back together. If I could get my slides up, I'll show you that not only was our last year's group interested in continuing, but we added some people. It's a nice big group this year, and they're very involved. We meet every week on a phone call, and we get a good crowd from this list. And everybody is very involved with we've turned it into two main topics. Last year we kind of did an overview of antennas. Everything we could think about antennas we tried to cover. And this year we're drilling down on a couple of topics. The two topics which were recommended to us to continue with, and mainly the things that we hadn't completed last year, were two. One is where we made the recommendation to incentivize the use of new improved antenna technologies. We now need to go into those new improved antenna technologies and learn all we can about them. Not just that they're new and fancy and have a lot of promise, but what are the actual technical details of these technologies that will affect how the FCC has to make rules to deal with them. And again, the other thing that we spent a lot of time on last year and needs some more time this year is that we're going to try to put together some kind of a group that will come to a consensus of what makes a good-looking small cell. And of course, the motivation there is that there's a lot of resistance to erecting small cells, and the vast numbers of cells that are going to be required for 5G mean that if we can ease the rollout a little bit by getting rid of some of the hurdles, then the entire 5G rollout should happen a little faster. So the first thing that the OET and the FCC would like us to drill down on is the actual technical details of the new antenna technologies that are going to be used in small cells and other places as well. So it's not just enough to say that MIMO is going to direct a beam, but once that beam is directed, this year we're going to study how do spurs, the off-frequency spurs, get through that same antenna. In the old days, the old knowledge was that a tuned antenna would act as an additional filter to help you reduce your interference to other services. But with these new broadband antennas that are highly directional and very programmable, we're not sure of that. So we're going to try to meet with people. Starting next week, we're meeting with some academics who have been studying this already for a few years. Another thing that matters is the pattern. We've all assumed up till now that the new antennas are highly directional and produce these little beams, but that's not exactly true. They can produce better beams, better directional beams of energy, but all antennas have side lobes. And all antennas are going to have a trade-off between how much calculation and how much time it takes to produce the perfect beam versus how much time do you have to get that signal out there. So we're going to be working on those things and hopefully give a much more realistic picture of these new antennas. The next topic that we're going to deal with is how can these antennas be used along with other factors such as multipath and other such calculations that allow us to create something that we call SDMA, or spatial division multiple access. It isn't just directing a beam of energy at the person who's going to be communicating with the antenna. There's also all kinds of other effects, and those can be taken into account, so that if you figure out how much energy is going to another place and then figure out how much of it is bouncing off somewhere else to go to that place, can you manipulate it to really create a small personal cell? Clearly, as we go to higher frequencies, some of the tasks get easier because we don't have to use such large antenna elements to radiate. But another thing that is going to complicate issues is that it's not all in one frequency band. 5G and other services as well send different parts of their signal through different bands. And how can you make one antenna or one antenna structure that will work on all those different frequencies? Certainly, and this goes toward our next topic, whatever we can do to make these antennas look better is going to help get them accepted. And finally, antennas are no longer going to be mounted on 100 or 180 foot cell towers. They're going to be everywhere. They're going to be on street lights and telephone poles and just about anywhere people can put them. So what challenges are we going to meet when we start doing that? Now, one thing that we're excited about with dynamic antenna systems is that they can precisely direct radiated energy and receive signals from a specific place. Thus, the same frequency can be used in multiple places, directed apart from each other so they don't interfere with each other. Certainly, by getting highly directional, and I mentioned we're going to drill down on just how highly directional highly is, and by having the signal be recalculated and bounce around to different users, plus we're going to have low antenna heights and a very significant down tilt, because in some of the 5G schemes that I've seen, most of the users will be directly below the antenna. The antennas aren't going to try and go for miles and miles. So all of those things can help to allow us to reuse frequencies and decrease the interference between that reuse. And of course, when you do that, you can share the frequencies. You can share the cell by multiple users. And in addition, it allows you to tune away from other services that might be interfering with you that have nothing to do with the communications that you're trying to make. So this year, what remains to be seen? First of all, we're going to study how tightly will the millimeter wave beams be focused. Certainly, there are side lobes. Even though a beam is focused, it still has side lobes going off. How much can we attenuate them and control them? The groups that we've gone to start our study of this topic are the IEEE Communications Society. They have a Future Networks initiative, and they're developing a roadmap for that initiative. And the first speaker that we have next week is a MIMO expert who's going to give us a tutorial on every technical aspect that we can try and get him to teach us. He studied digital versus analog MIMO. He has a great understanding of the beam patterns. And he has worked on interference suppression. How do you set up nulls so that you don't hear other people coming at you? And he also is going to talk to us about how millimeter waves propagate, because that will have a big effect on how you design your antenna structure. Now, our second topic is to, there we go. We suggested that we make antenna structures look better and be more acceptable to communities, so that when each tower goes through it, or each small cell even goes through its zoning process, it doesn't meet a lot of obstacles. The one way that we thought would be the best way to do it is build a multi-stakeholder group. Don't just have a bunch of engineers decide what a cell should look like, but rather get engineers, get other people who are going to have to look at these things to say what they would like to see. And then together they can make those decisions. Our goal is that this group come up with a best practice and that the industry would accept for installing small cells. And if that best practice is based on what the people in the communities are looking for, and it's based on the technical requirements of a small cell, then hopefully the small cells will go in much more quickly. We're going to have the we're going to talk to people who might make up a multi-stakeholder group. We're not going to create that group ourselves, but we'll make recommendations on how that should be done. And in addition, in conjunction with the 5G IoT working group, we're going to be putting together, and very soon, a public notice, something like what we've done before, where we put out a notice asking people to give their opinions on this topic. And we'll write something up and get it out there, and probably allow 3 to 4 months for replies. In the past, that has been very eye-opening. When we go out just to the general public, and it's amazing how many people actually pay attention to the FCC website and realize that there are questions that we're asking them to answer. And we'll go over those and hopefully add to our knowledge of what's desired from the small cells that will be covering the nation. But we've already come up with some examples of objectionable installations. You've seen this before. I want to show it one more time. These, in every way, even to me, are somewhat objectionable. They have wires hanging, which doesn't seem like good engineering practice, certainly not very reliable, but I'm sure it was very cheap. And we need to get the industry to agree that very cheap is not always going to work for them. But we also found that it was possible to make that same electronics and antennas look good. And here are several examples. They go into light poles. The electronics can sit in the base of the light pole and not look much like electronics. Even on a wooden pole, which is more difficult, you can hide the wires and stick a nice antenna at the top, and it almost fits in with the wooden pole itself. And this year, we are going to talk to some of the people that helped design those. And also, in one place in Boston, they probably have one of the most advanced sets of requirements for these, and we're talking to the person who set those requirements up. We're going to ask him to speak to our group. Now, another thing that we learned, just in the short time already, is that a lot of communities aren't thinking about what a small cell looks like, but rather that there's going to be a lot of them. And in many communities, and I'm not talking about the inner city, but more suburban and just slightly outside of that, areas where you don't have poles every block or every few feet even. And they're worried that that's what's going to happen. They're going to be poles erected all over to make it look like a forest. So one of the things that that could help with that, and I'm expecting that we're going to hear a lot about this, is that wherever a small cell can be shared between multiple vendors, it's going to help with that concern. One of the groups that we talked to designs such things, and this is just a single canister, but it will support multiple vendors and multiple frequencies, all in one canister. And the advantage of that, obviously, is twofold. One is that in one structure, you're supporting the many frequencies that you need to cover. And also, you can, in this particular one, you can support 4 different vendors in this one canister on all those frequencies. Another example is a slightly smaller thing that isn't quite as big, but it still will support multiple users, so 4 users and not quite as many frequencies. But it certainly, from the outside, might prevent people from having a concern about the looks of these antennas. Now, the multi-stakeholder group has several advantages. We learned already that even though there were some regulatory regulations made requiring or that we're trying to require small cells to go in more quickly and easily, whenever you make a rule, someone else can figure out how to get around that rule. And one that surprised me, there was something that sounded really smart to me, the shot clock. You know, once an application is made, the community has a certain amount of time to approve it. But it turns out that the shot clock is so easily circumvented, if you ask them to change the color, the shot clock is restarted. If you ask them to change any small detail, again, the shot clock is restarted. And this one particular antenna builder was telling us that they've had applications go on much, much longer than one shot clock, many, many shot clocks, because the communities have learned how to game this system. And he also told us that they go to some municipalities and say, well, the regulations say this, and they say, tough, sue us. And very often, the companies aren't willing to do that. So the communities, the municipalities get away with it. So what our thinking is that if we have a group that represents those municipalities, and that group agrees to certain guidelines, it's more likely that the municipalities won't put up so much resistance. In addition, having technical representation in the group is also important. We heard that one community insisted that the antennas be mounted underground because everything else in that community is underground, so why shouldn't their antennas be underground? And you know, the regulation allows them to circumvent those kind of ridiculous regulations, but I shouldn't say ridiculous, but those kind of extreme and unusable solutions. So if with technical representation in the group, we should be able to have guidelines that are both aesthetic to the municipalities and possible and buildable and affordable. Because obviously you can make anything with enough money, but no one's going to do it. Some of the groups that we've thought about for this multi-stakeholder are cellular industry representatives, obviously, either from the individual companies or from industry associations. We are talking to some local zoning representatives, particularly this one in Boston that's been so successful. And in many states, I think it's up to 27 now. 27 of the states have now circumvented or superseded the local zoning so that there is a single state zoning. So we'll talk to some people from those state zoning boards to figure out how they made their decisions. In addition, we'd like to find someone who can tell us about both technical and aesthetic design requirements, and other people who are going to talk to us about what does it cost to build some of these things, what's realistic. And finally, there are some companies that build towers, and the individual cellular providers use these tower builders, and they have a lot of experience with all kinds of different small cells and large towers. Some of the groups we've considered, the National League of Cities, that indirectly represents just about all the cities in the country. I think directly they represent the state municipal associations, which then represent the individual municipalities. The cell site providers, we've talked to one, and we're going to be talking to several others. We would like to consider CTIA or PCIA for representation, or just certain of the individual providers. And finally, the suggestion was made that we go talk to the American Institute of Architects and see what ideas they have for nice-looking small cell sites. So obviously, we have our work cut out for us. It's going to be a short year, but a very exciting one. And I guess our next meeting in September, we'll be able to present you with much more detailed information. So thank you very much. Let me give it over to Marty for some comments.
I just wanted to make one comment. With all of the emphasis that Greg has stated about small cells, the opportunities are much bigger than that. We now have the ability with combining antenna arrays with lots of processing to shape coverage patterns, to control all kinds of characteristics of what the energy transmission is. And the result of that can be much better use of the spectrum, more spectral efficiency. And so somehow or other, we have to come up with recommendations to the Commission so that they can get us to avail ourselves of the capabilities that these antenna arrays will happen. If we don't get better spectral efficiency, if we don't get better control of our coverage patterns of interference, we will not avail ourselves of the possibilities, and the possibilities are really endless. The potential is, and I've been saying this for a long time, that there is an infinite capacity of the spectrum if we only learn how to control the energy that we're transmitting, and I believe we are moving in that direction, and I think that's the biggest emphasis of the antenna systems group. I ought to point out that somehow the term antenna, we wasted a little bit of time studying antenna elements and discovered pretty much that not much has happened in the technology of actually creating a radiating element. The opportunity is arrays of elements processing, and so I just wanted to clarify the use of that term.
Great. Thank you very much for the presentation and for all of the good work that was behind the presentation. Just particularly for our new members, 8 of whom are around the table, if you have questions or comments, our protocol, and this is not unique to the TAC, is to raise your tent card. But let's move to that portion of the discussion for those that have questions or comments or observations they'd like to make. And Dale, why don't you open things up?
Well, thank you, Dennis. I have had some recent experience with some siting issues in a couple of the areas that I work in, geographic areas. And what we're seeing here, I think, to some of the local opposition is framed in terms of densification. But the issue is, the elephant in the room is really RF exposure. So one of the reasons I believe that you see people slowing down is because they're worried about and don't have enough information about RF exposure. Now, when I look at the opposition that I've seen locally, quite a bit of it's, well, I shouldn't say quite a bit, but at least a portion of it is badly misinformed. But that's part of the problem. People need to understand when you talk about densification. Is densification a good thing? Or as we know, densification can be, densification can help because it reduces the amount of handset power you need in some cases. So people think, oh my goodness, it's going to be worse, but it could be better because if I understand, the base station signal falls off really rapidly. So once you're 10 feet away, there's probably no issue. But that raises, I don't know where the commission stands today on how you have exclusion zones, right, for big towers. People are not supposed to go in things. Does any of that apply here? These are all questions that I don't think people have bad motivations. Is they legitimately don't understand it well enough to feel confident. And so while we can go after aesthetics and make the antennas really, really look nice, unless you deal with the underlying problem, you'll continue to see slowdowns and things like that, because they're sort of a surrogate, if you will, for our exposure issues.
Marty, did you wish to respond?
Well, Dale, I think you're right. If you look at the literature, it's highly polarized. The scientific evidence is such that there really is no RF exposure problem. There are a lot of people that are presenting papers that look very scientific, that are warning people about how serious the problem is and how you ought to use all kinds of different gadgets that we know don't work. So perhaps that ought to be part of our mission, or the FCC's mission, to try and educate the public that the FCC does have rules and regulations that in fact take on this problem, and that there is no technical problem with RF radiation. But a lot of people worry about it.
So,
if you want to speak.
If I want to speak. So a couple of things. First of all, we do have rules in place. And they go all the way up to 100 gigahertz. The folks who are deploying the systems are responsible for compliance. When we do any kind of an analysis, when somebody has raised an issue, the signals fall off so rapidly that invariably there's a big margin of compliance with the accepted standards. We do have an open proceeding. I think there's perception, because it's been open for a while. It was an inquiry that there's not work going on, but there actually is. So stay tuned. And we appreciate the desire for more information. And we hear that. So I don't think we intended to have our exposure be part of the scope of the work here for this group, because it's a whole different set of issues. But we work closely with the other agencies. Food and Drug Administration, they had issued a statement that the existing standards, I think, are continuing to be appropriate. So we're continuing to work on the issue. We take compliance seriously. And I think that's about it for...
My response would be that we need to get that message out to the communities. In other words, if there is no problem, this is an advisory committee with very, very wise people on it and so forth. And we need to give people some comfort that at these millimeter wavelength frequencies, we've done enough studies to conclude that there's no issue. Somebody needs to get that, or we'll continue to get local opposition.
It is one of the challenges. Actually, I've been involved in that particular area for many, many years. Let's move to Michael.
Greg, I'm wondering, with cities becoming more proactive in deploying their own IoT infrastructure, sensors and cameras and such, do you see more of a willingness with local government to try to tackle some of the same challenges with industry in terms of, the aesthetics and the placement and so on?
We hadn't really talked about that or thought about it, but it's a very good point. And we do, even though that slide was full, I do have room for more names if you're at all interested. And then I'll take this opportunity. I don't know how people get recruited to different committees, but anybody who heard what we said and is interested in working with us, give me an email and I'll add you to our list.
I have to tell you that there is a wide variety of local communities, and most of them are interested more in whether they could extract more money out of the carriers. Some are interested in the aesthetics, others are interested in how much it's going to cost them to allow deployment of these antennas. I think the leadership has to come from the commission. We somehow have to think about the broader impact of how important it is that we have complete coverage. So, as I say, I think the leadership has to come here. We can't count on the communities.
Michael.
Yeah. Hey, thanks. Marty and Greg, I think the aesthetic is an important topic, but also wanted to go back to the first topic, which is the millimeter wave, whether we call it beamforming, arrays, there are a couple of different names. Since we adopted the rules for the millimeter wave bands about 3 years ago, I think we've been working very hard to deliver some of these products out to the market. But now they are actually getting deployed, and I think we need to do a little bit more work to better understand how these antennas really work. For example, we are kind of challenged with, if you look at the traditional antennas, we have these antenna patterns that we have used in decades. We got a plot for the elevation, or the azimuth angles, and you have all the gains and nulls, and we know how to use it, all that. When it comes to these array antennas, we're not really sure exactly how to represent, how to characterize the antenna performance. Are we using these similar plots that we've seen before, but what does it represent? Are we looking at multiple beams or single beams? Do we have some sort of a consensus industry that, hey, that these beamforming antennas should be represented in such a configuration, and then the plots will be representing X, Y, and Z? We have a lot of different discussions, but we don't really have a consensus from the industry. And we have all the members from, range from Samsung, Nokia, Ericsson, who are the major technology manufacturers and leaders, as well as some of the smaller companies and all the experts that we can tap into. It will be really helpful for the commission, especially our folks at the lab, who are dealing with day-to-day certification issues. And then also when we try to run some interference analysis, there needs to be some sort of representative characteristics of these antennas. And people would try to pick out the worst case scenario, and then we get into the arguments of, is that really the operational scenarios? For example, if you have a certain degree of a down tilt of the antenna, what does that mean for the beamforming? Does it really change the antenna performance and characteristics because you have a 2-degree down tilt? We know how that works on the more of a fixed antennas. In this case, it's not really sure to us. And also, when we say we're doing a beamforming so that we create huge gain towards a certain direction, we wonder ourselves, what does that mean for the out-of-band emission? Does out-of-band emission characteristics get the beamformed just like the way that the in-band signal gets beamformed? So there are a lot of unknowns, and I'm sure a lot of people start learning what that means and so forth. And I really like to, last year I think we got certain discussions, and a lot of good experts came and gave us some advices. And this year we'd like to kind of follow that up with a second layer of the question, so that it will really help the commission to continue the certification process, as well as as we deploy more systems. I'm sure we'll be facing some of these tough questions, and we'd like to get some feedback in advance so that we will have a more constructive discussion down the road as more systems gets deployed.
In other words, if you could just produce a modest-sized textbook that covered all of these topics over the next 6 weeks or so, that would be quite adequate.
One of the problems we got is using the term beamforming. We're not forming beams, we're containing energy, and somehow we have to change the whole semantics of how we talk about this problem. And I agree with you, Dennis. This is a really hard problem. It's not an easy one.
Good. Marvin.
I
wonder if we aren't actually narrowing the problem a little bit too much. We just talked about beams and down tilt, but as we'll probably hear from the drone group, pretty soon we're going to have beams going upwards as well, and coverage overhead, and optimizing now may put us in poor position a few years from now when we want a different set of patterns. The second comment has to do with the discussion of smart cities and sensors. And again, if we optimize a cellular antenna, cities may say, well, that's not our problem. Our problem is we need to put a whole set of things on top of a light pole, of which cellular is just one. And we want to optimize the whole problem, the city Wi-Fi and cellular and sensors for traffic and so on. And we want to design that doesn't have look like a Christmas tree, because we end up adding all of these other sensors onto it. And so unfortunately, the problem may even be larger than has already been described.
Oh, very good. Ted, you've been patiently waiting down there.
Yeah, I want to come to back to Dale's point, and just call attention to the group and the commission that we studied the health effects issue in great detail in 2015 and published a paper called Safe for Generations to Come, which goes through the global regulations and all the literature that's been out there and on the work of government bodies and researchers around the world. So Safe for Generations to Come articulates that. And then another paper that same year, 2015, called The Human Body and Millimeter Wave Wireless Communication Systems, Interactions and Implications. So you could look for the human body and millimeter wave wireless, and you can look for Safe for Generations to Come. And I did that work with a professor in radiology, where I also have an appointment at NYU and a grad student. So there's a lot of detail about that, and I get a lot of questions about that from the popular press. But I think you're right. There's a perception issue, you know, a lot of work was done in the 90s around the world on this. And, but I think to the point being made about, that Marty made about, as we move up in higher frequencies, and Michael, you made this point, as we start using adaptive arrays with multiple antenna elements, as I gave a presentation of the TAC last year, it's going to become important to understand how those adaptive arrays work and how you measure the energy as a function of distance across different manifolds, different physical architectures of the antennas. And that would be a good area for, I think, us to look at.
If I could impose on you, Ted, could you send the references for the two papers that you just cited to the TAC?
Sure.
That would be great.
If we're going to do that, it seems it would be fruitless to right now. I believe there's even meetings going on in Europe right now on some of these RF exposure issues. So I take your point very well, Ted. But I think if we're going to do this, we need to make sure we have the latest information that we're distributing, rather than something that's a few years old now.
Should I not send them?
No, you should send them. It's okay. But Dale's point is good. If there are other references, that'd be great too. Tom.
Yes, and I did add that we're putting together at CTIA a reference site of information, frequently asked questions about our safety and health, as well as some of the research information that we have, as well as what other government agencies have been saying about it. So as soon as that's ready, I'll share that with the group.
Great. Yeah, I mean, it's certainly a topic of great interest. Steve?
So I do agree that we need to address the safety concern, and I think that that's something that does need to be looked at. But the thing I wanted to really bring up was going back and looking at new manufacturing processes for antennas, because I believe that does give rise, as Marty pointed out, to much better spectrum reuse and reductions in interference. So I would encourage the working group to focus on that.
Great. There are no more tent cards around the room, so are there any questions from those on the phone or comments? Hearing none, we will proceed, and thank you again for all of the good work for the antenna group. And based on the comments here, the amount of work that remains has just been ratcheted up, which is often the case as we come together, but really terrific work that you're proceeding with, so thank you.
Thank you.
And we'll move now to the 5G and IoT group, and John is the one in the room, but we have both Brian and Russ on the phone, uncharacteristically on the phone, but all three present, so I've seen some of the emails back and forth on how you're organizing things, so I don't know whether you want to lead, since you're physically present, John, introduce who is going to do what to whom?
I will say that I am adept at changing the slides for Russ and Brian, who will be on the other end, and I'll try to keep up. And in the middle, Marty and I will have a word or two to say, but generally it's going to be Brian doing the presentation.
Okay.
And yeah, thanks, John. This is Brian Daly again. Again, apologize that neither Russ or I could not be there in person today, but we do have a good presentation to go through. So as mentioned, both Russ and I lead this working group, and John has graciously taken over the leadership of two sub-working groups we have, one on spectrum and one on rural, and we'll get into those a little bit during the presentation. So we can move to the next slide, John, slide 2. This is the makeup of our team. As you can see, we've got good representation from many different companies and organizations represented. So we're looking forward, again, to a productive year. Those that are in blue are our new members that we've brought on this year, and that will be helping us understand 5G and IoT. If we can move to slide 3, and I'm not going to read through this entire slide. As you can see, there's a lot of information here, but it talks about our charter for this year. Specifically, we're going to continue on with the work that we provided last year to look at information on the development of 5G and IoT technology and make recommendations as it evolves. And as you can see in the slide, there's a number of questions that we've identified that we'll attempt to address during our work this year. We can move to slide 4, please. Some specifics on the charter. We understand that 5G is certainly a critically important topic to the communications industry, but more broadly to the economy and U.S. international competitiveness. I'm sure everybody has picked up newspapers or looked at the trade journals and seen a lot about this in the recent months, so we don't need to delve into that more. We want to provide insight into the development of the technology and make recommendations as it evolves, and also focus on technical insights and recommendations. Slide 5. We have a number of charter questions, as I mentioned, that we're going to try to address this year, specifically looking at different frequency bands, how they're being used in deployments both here in the U.S. as well as internationally, the status of deployment of vertical services and specific vertical industries such as energy, transportation, healthcare, et cetera. What technical steps are being taken to make sure 5G services are brought to the rural areas, especially when we look at such applications such as low latency dependent applications? How do we make sure that the rural areas are also served by the capabilities that 5G is going to offer? Next is how 5G capacity, speed, and latency playing out in general and by application and by geography. Considering that it's going to be a long rollout, What is the evolutionary path of 5G, and where will this lead in terms of new functionality to meet the needs and desires of the U.S.? And to the extent 5G is making a difference for IoT deployments, how is that going to evolve? And also, what's the status of satellite offerings for 5G service? And what new developments have arisen that the Commission should be aware of or address? So if we move to slide 6, we'll take a look at what we did during the second quarter of 2019. Slide 7, please. So we've had a number of presentations and subject matter experts come and talk to us on different topics, CBRS being one, rural manufacturers as well as spectrum. We looked at standards activities and tracked what's going on in the standards, and try to understand what the worldwide deployments currently look like. We've addressed some of the 5G IoT vertical impacts, sub-working groups focused on spectrum, both licensed, unlicensed, dedicated, and worldwide activities, as well as the 5G rural and underserved opportunities and issues. And with the antenna group, as mentioned, there's an overlap between the antenna that was just brought up in the aesthetics. So we're going to follow up on a 2018 public notice. Some of the other areas we're investigating is 5G spoofing and jamming, as well as 5G drivers related to IPv6, how satellite services come into play with 5G, and the new 5G related developments. Next slide, please. Slide 8, this just is an overview of some of the speakers that we had in our working group to date. So from Evolve Cellular, we looked at the rural specific antenna development, high power on front and backup plus, and unlicensed lacks investment traction. Needy Tandon from AT&T came in and talked about some of the CBRS areas. We had the CBRS Alliance also come in to bring us up to speed on CBRS. We had 5G Americas talk about their update to their 5G security paper, which is going to address some of the IoT requirements for a comprehensive security approach and looking at some of the threat surfaces. NIST came in and talked about the fact that the factory wireless has strict QoS and latency requirements, and no one-size-fits-all solution is available. And they looked at several use cases, varying requirements. And then finally, T-Mobile came in and talked about 600 megahertz and mid-band for rural, and also mobile broadband and fixed broadband in the rural. Next slide. We also looked at the deployment update to see where things are headed with 5G deployment. So if we move to slide 10, what we found is that the forecasts are 10 million 5G subscriptions are projected by the end of this year, and by the end of 2024, the projections go out to 1.9 billion 5G subscriptions for enhanced mobile broadband, and over 20% of all mobile subscriptions will be 5G in that time frame, with 5G networks carrying 35% of mobile data traffic globally. And the 5G coverage, we expect up to 65% of the world's population in 2024, with radio deployments in new bands in the sub-6 gigahertz range, and deployments in millimeter wave frequency bands to reach 45% of the population, and deployment in existing LTE bands to reach an additional 20% of the population. So what we're seeing out of this report is faster than expected. The enthusiasm for 5G has led Ericsson to forecast an extra 400 million enhanced mobile broadband subscribers globally by the end of 2024. Next slide, slide 11. This is a summary of what's happening in the U.S. We've got Verizon with fixed wireless 5G operating in 4 cities, mobile 5G operating in 2 cities, with plans to have service in 30 cities by the end of the year. AT&T has mobile 5G coverage in 22 cities and has announced nationwide coverage next year in 2020. T-Mobile has a commercial 5G launch in the second half of 2019, launching in 30 cities and nationwide coverage expected in 2020. Sprint is deploying 5G in 9 cities in the first half of this year. U.S. Cellular has 5G services coming in the second half of this year. C-Spire has fixed 5G services in Mississippi. Charter has testing 5G, but doesn't have any published rollout plans at present. And Starry has fixed 5G currently in 5 cities. So if we add this up, there's a total of 95 city deployments that are currently in the U.S. Next slide, slide 12. So if we look globally, there's an investment by 224 operators in 88 countries. So we're seeing a number of fixed wireless broadband networks tests and trials, as well as mobile network tests and trials. And as of April, 39 operators have announced either non-3GPP compliant or 3GPP compliant 5G technology deployments. This includes 15 deployments that are 5G mobile or fixed wireless access services, and 13 deployments that are 3GPP compliant. And there are 6 UK cities have launched on May 30th in the UK, and in South Korea, SK Telecom, KT, and LG U+ launched 5G fixed wireless in December of 2018, which was the first country worldwide to launch full 5G commercial services. And as of June, the number of subscribers are approximately 900,000. Next slide, please. So looking at where the standards are, if we move to slide 14, Release 15, which was the first release of 5G, as you may recall from previous presentations of this working group, they broke up the deployment into, or the standards into 3 drops. The first drop was early to provide a head start for the chipset manufacturers. The second drop in June of last year was the majority of the release, and this late drop completed 2 additional non-standalone options that have just completed in March of this year with the AS.1 syntax in June of 2019. Release 16 is the next major release, and this will be complete in March of 2020 with the ASN.1 in June of 2020. And what this includes are things such as enhanced mobile broadband enhancements. Enhanced mobile broadband was really the prime focus of Release 15, although there was some ultra-reliable, low-latency work that was done as well. But the Release 16 really is going to focus on the remaining use cases, including bringing things such as slicing, ultra-reliable, low-latency communications, V2X positioning, 5G satellite, and study of enablers for network automation for 5G. There's also the use of multiple access technologies for simultaneous services active on a UE that's going to be part of the Release 16 package. Release 17 is already underway, and the goal is to get a final agreement on the timeline at this December plenary meeting. And stage 1, which are the requirements, are targeted to be complete also in December. And some of the potential areas being looked at are the verticals, such as healthcare and UAS, new radio evolution, integrated access and backhaul, enhancements such as relays, edge, and proximity services, and support for millimeter wave above 52.6 gigahertz. The ITU, which is has the IMT 2020 submission, is going to have that submission update and self-evaluation from 3GPP is targeted for October, with the final in July of 2020. Next slide, please, slide 15. Addis is also developing a number of 5G related involved in a number of 5G related activities. And as you can see at the board level, they do have a 5G strategic initiative, also cybersecurity, which is a big focus area in 5G. Some of the verticals such as smart cities and unmanned area vehicles. Looking at technology and Operations Council is looking at 3GPP for Release 17 and beyond. And the TOPS Council is also looking at things such as the location accuracy test beds and database. The committees are also engaged in 5G-related activity. And, of course, Addis is deeply engaged with 3GPP through its international partnership. Next slide, slide 16. So this is the current schedule that's being worked within 3GPP. As mentioned, the Release 16 schedule shows the freeze in the first quarter of 2020 with the Release 16 code freeze in the second quarter. Release 17 planning is underway, as mentioned. Try to get that timeline fixed in the fourth quarter of this year. But the current working timeline shows the Stage 3 freeze for Release 17 completing in the second quarter of 2021 with the Release 17 code freeze in the third quarter. And again, this is a preliminary schedule based on the working assumptions that have been made at the last plenary, and they'll be finalized at the end of the year. The other thing to note in here is that Release 18 is already showing up on the timeline. And later this year into the first quarter of next year, the initial input for the Stage 1 requirements will be under development within 3GPP. Next slide. So now we'll look at the 5G IoT verticals and some of the areas that we've been focusing on here. So if we'll move to the next slide, slide 18. So we're investigating, several different areas that we've identified that we should look at. The first is industrial IoT, and some of the services that are needed in here, including ultra-reliable, low-latency communication, as well as industrial automation and control. The second one is the enterprise for fixed wireless and collaboration. The third is transportation, looking at connected transportation, maintenance, and entertainment. The next one is healthcare, which will have massive data sets and real-time needs. And then finally is energy, which will require sensification, that is a lot of sensors, the smart grid, meters, homes, and industrial. IoT is going to have significant impact on vertical device connectivity, and is certainly an area we're going to spend a lot of time as we progress through this year. Next slide. Slide 19. So this is a vision of wireless in the factory that we received from Richard Kandel of NIST. And when we look at the technical drivers and key requirements, we have multiple reconfigurable and collaborative mobile robots in the wireless factory. We have real-time movement and tool coordination, which requires sub-millisecond latencies, as well as ultra-reliable communications with simultaneous redundant channels. So what we see is a number of work cells that we might have within the factory that have sensors, actuators, robots, and controllers that are all being controlled by automation servers providing operational commands, scheduling, design, code, and work instructions. The feedback back to these operational centers provides status, metrics, and production results. And all of this requires connectivity and communication between the different entities that are part of the wireless factory. And, this is one of the use cases that, definitely will be focusing on as we explore the IoT. Next slide, slide 20. So the next area, and this is a sub-working group that we just started, is to take a focused look on IoT spectrum. 5G and IoT spectrum. So if we go to slide 21, so what this slide tries to show is that there's really a broad range of spectrum requirements for 5G. A lot of times you see a focus on the millimeter wave technology for 5G, but when you look at the full range of services and the full capabilities of 5G, it really goes much, much beyond the millimeter wave. There's low band, mid band, as well as the millimeter wave high band at each consideration. And certainly when you think of the high band millimeter wave, you think a lot about the capacity. And you get the high bandwidth supporting the enhanced mobile broadband because you have more spectrum available to provide that capacity. And you think less of coverage because as you move up into millimeter wave bands, the propagation characteristics are such that you don't get the broad coverage. When you look at the other end, the low band, it reverses. You think of the low bands providing the high coverage, but you may not get the full capacity that you would see in high band millimeter waves because your spectrum availability is not as great as you would get. So when you put this all together, you know, you have the range of spectrum that's available and the different types of services that are supported in the different regions where you would have that. And this chart tries to depict that on how the different bands are needed for 5G and what the support might look like for those. Next slide, please, 22. This is a global snapshot of the 5G spectrum bands that are either allocated or targeted with the U.S. up at the top. And as shown here, there's a combination of licensed, unlicensed, and shared, as well as the existing LTE bands that are depicted here. And as you can see, you know, the U.S. has quite a bit of spectrum that's either allocated or targeted for 5G, and again, that's an important consideration as you move and look at the 5G services, especially the previous chart that shows the wide range of spectrum that's needed in order to support the different use cases that you have for 5G. Next slide. Looking at worldwide spectrum in Europe, there's a focus on mid-band and 26 gigahertz for 2018 and beyond. The key European members are driving activity to accelerate the 5G rollout in the EU, and there's intense regulatory activity for 3.4 to 3 and 26 gigahertz with auctions expected into this year. Next slide, please, 24. So this just continues through the various countries. Again, I'm not going to spend the time to go through each one here, but we did take a look and got some information from each of the countries in the EU and tried to highlight and summarize them in these slides. Next slide, please. In China, South Korea, and Japan, again, these slides summarize our findings on what we see in that region. In China, there's an allocation in 3.3 and 3.6, as well as the 4.8 and 5 gigahertz as official 5G bands. And China Mobile received a 5G trial license for the 2.6 gigahertz band N41. Millimeter waves looked in the longer term. And again, there's some small-scale trial usage, and there's additional low and mid-band spectrum that's been assigned. In South Korea, there's 5G spectrum for sub-6 and millimeter wave, with 5G service launched this past March. And in Japan, the 5G rules for the bands listed there are specified, and their spectrum blocks have been awarded to NTT Docomo, KDDI, SoftBank, Rakuten, as indicated. Next slide, please. And then Southeast Asia and Australia, again, I'm not going to go through these in detail, but again, there's been a number of movement on spectrum in this region as well, and those can be shown here. And slide 27, moving to Latin America. Again, won't go through these in detail, but as you can see, there's a number of movement on different spectrum bands in South America as well. And slide 28, again, this is the 5G, little different picture of the 5G global frequency summary. And this is more pictorial view of where the spectrum allocations are for each of the regions and countries that we have just gone through. So if we move to slide 29, again, in summary, what we see is that mid-band really dominates for some of the spectrum allocations as we look worldwide, with millimeter wave part of the first wave in most countries. And what the particular mid-band and millimeter wave assignments you can see here summarized on this slide. Moving next to slide 30, this just is the overall frequency allocation chart here in the U.S. Pretty much covers the entire broad spectrum from 300 kilohertz up to 300 gigahertz. So just in here for reference on where the various frequency bands reside and what might be surrounding them in those allocations. Next slide. So when we look at different options for spectrum policy, obviously first one was licensed spectrum, which is a strictly regulated approach, clear separation of deployments in time, space, time, and frequency. And this is typically how national operators acquire access to spectrum. The second policy option is unlicensed spectrum, where all devices can access the spectrum. There's no control of the number of devices. And this is typically, for example, how Wi-Fi network operates. And the current U.S. allocations of unlicensed spectrum are more than 500 megahertz in low bands, 14 gigahertz in millimeter wave frequencies, and up to 1.2 gigahertz if the 6 gigahertz allocation becomes policy. And then the third policy option is locally licensed or shared access, including dedicated. And this would be a regulatory framework that allows for several users in the same band. And the quality is pending the national regulatory framework. There's 3.55 to 3.7 in the U.S., 3.7 to 3.8 in Sweden and Germany, and 3.8 to 4.2 in the U.K. So next slide, move to slide 32. Licensed spectrum, this was responsible for creating the mobile telephone revolution with the vertical service model for voice, SMS, and circuit data. Packet services created an informal information revolution by bringing the internet to the palm of your hand, and further expansion promised by cellular IoT. License does provide a mechanism for delivery of information services, including media, broadcast, and interactive services, and a significant realization of immediate value by forcing investment into infrastructure. And 5G is going to harness the technological solutions to bring support to more verticals. And this would include public services, transportation, smart utilities, industrial wireless for monitoring and critical communication. Next slide, slide 33. So one of the debates is, should there be more licensed or more unlicensed? The license model only carries so far with all use cases. Service providers are motivated on return on investment and create products that maximize the revenue potential for spectrum. So what is the role for network slicing in being able to dedicate resources to critical societal needs? And how many use cases are there that would need their own spectrum and can fill that allocation with traffic? And will this dedicated or shared licensing lead to more innovation? When we look at these public safety and QoS sensitive applications, transportation, industrial automation, rural broadband, those are all areas where adequate support is currently lacking. And can some of those services be done over the top? Is spectrum sharing the proper approach? Or is there a solution of providing dedicated spectrum for certain verticals? And that's the conundrum. With limited spectrum, how do we meet all these needs? Next slide, slide 34. So the dedicated debate, how do we drive innovation, economic development, and meet the needs of key industry verticals versus use of non-dedicated spectrum? If we look at the top industrial IoT manufacturing markets, clearly you see, in the U.S. we have alternative methods of spectrum allocation and leasing and shared. We've got the 3.55 to 3.7 CBRS, 37 to 7.6 gigahertz, as well as 3.5 gigahertz in the UK. There's discussions for dedicated spectrum for industries ongoing, and those are listed there in Sweden, Germany, 37 gigahertz, for example, in the US. Next slide, slide 35. So mid-band CBRS introduces a three-tiered shared spectrum, and this is a good opportunity for spectrum users. You've got the tier one incumbents, such as Navy radar or fixed services, where the incumbents are protected from interference from the priority access license and the general authorized access. The second tier, the access licenses, they have priority over general access via auction with 10 megahertz blocks up to 7 licenses. And then the general authorized access can use any spectrum not used, but have to yield to both the priority access users as well as the incumbents. CBRS will most likely not be used for critical services because of this three-tiered spectrum sharing. Next slide. Some other spectrum observations. China and other countries are focusing completely on sub-6 gigahertz spectrum for 5G, mainly to get greater transmission distance, reduced interference, and as a result, fewer antennas. The balance of licensed, unlicensed, and dedicated or shared is very complex. And how do we meet citizen business needs while stimulating investment and innovation is really the key. Spectrum reuse and shared are potentially ways to optimize usage. CBRS has the potential to provide spectrum both for private use and industry-specific needs, but it does lack some capability to fit verticals and users that demand determinism, such as industrial and critical services. The spectrum management here in the U.S. Is very proactive and is looking at a broad range of spectrum, both low, mid, and millimeter wave. We feel additional focus is needed on mid-band, including C-band. Millimeter wave is not a good fit for rural deployments. The densities and distance challenges of the spectrum is really what drives that conclusion. Optimizing spectrum utilization should be a top priority. How do we measure success? The TAC is going to further investigate these areas for potential opportunities and recommendations. So now we move to slide 37, the rural and underserved update, and I'll turn it over to John to give the next couple of slides, and then we'll pass it to Marty.
Okay. Well, Brian, get yourself a drink of water. That was a long, a long slog. We'll give you a brief respite here. So he just forecasted part of the issue with the rural market. With all the investment going into 5G, a tremendous amount of that is going into how to make the data services more dense, how to get faster speed, how to cover cities and in very populated spaces. And with all that focus on millimeter wave and antenna densification, the rural market sort of has the opposite problem, where there's more of a premium on coverage than speed or reliability. So if you look at the 5G investment that's out there, only a portion of that is really going to apply to solving this divide that has emerged between the urban and suburban spaces versus the rural market. So what are the kind of things that 5G doesn't address in the rural market? Well, coverage, the spectrum needs, the backhaul cost, which are still, we heard from one speaker, prohibitive and stop them in their tracks from expanding into a new area. The interconnect costs still are higher, as are the antenna cost to adequately cover that range. So what's it going to take to solve the problem of getting higher speed access available in the rural market and closing this rural divide that exists? Well, the problems they've got, of course, are low population density, broad geographies they have to span. It's more expensive to put up all the antennas they would possibly need to serve all their communities at a lower density. Backhaul cost still a problem, and then the bands they need are all on the lower end of the scale in that market to be able to get the propagation that they need. So solving this problem is going to require more than just the 5G. So there's not a silver bullet. 5G is not a silver bullet in this market. We're going to need a solution that incorporates the developments in the satellite area. We're going to need to continue to rely on Wi-Fi, LTE, LAA, spectrum policy that comes up with effective ways to share spectrum in that market, antenna design that's more efficient for these types of bands in the rural market, backhaul, and then the rural funding is going to have to be addressed in such a way that the economics of closing the divide are sufficient to actually incent investment in these lower population density areas. So when you look at the bullets on the right, we're going to try to tackle a number of these in our sub-working group this year. Particularly, Russ has reached out to Greg about talking about antenna design. And we're just going to go through all the different barriers that we've identified and try to address this as we go forward. Now, one of the interesting things that has come out of this discussion in rural is we discovered that our godfather advisor here, Marty
you referred
has
to as
been
a number of things, but not godfather before. So,
El Padrino. That Marty has been addressing this discussion in a book that he has been writing, and he shared his chapter on closing the rural divide for education. And so we decided we wanted to incorporate a preview of that into this session, and we're going to let Marty talk to some of his observations as he's been studying this issue and the potential solutions for it.
Well, I just wanted to start by reminding the group that the purpose of technology is to make people's lives better. We tend to forget that. And so when we started to look at the rural issue, coverage in rural areas, we took a different view of that, and that is to look at the priority of education. And the observation that came out of this is that we are approaching a crisis in this area because we have some new techniques going on in education that in fact it's been determined that when you start educating people in the way that we all really get educated. Our education really don't start till we get out of school. And the way we learn the most is by solving problems in the real world. And when in fact you adjust the educational system to do that, and we are doing that in all kinds of places with concepts like the flipped classroom, that people's brains actually become more capable. They grow, there are more interconnections, they grow faster. And the conclusion is that people who have access to wireless coverage when they're being educated will end up with bigger brains and more ability to cope in the society. If you consider the fact that in rural areas there are marginal coverage. One of the statistics is that 40% of our schools don't have internet access. When you put all these things together, we have the concept of the digital divide really becoming serious, that it becomes a digital chasm with, on the two sides, the smart people and the dummies. That's just an unacceptable situation in society. So I took a look at this thing and first of all considered how do you optimize covering of rural areas. And it turns out that almost everything you do in 5G is antithetical to what you would want to do in a rural area. And the conclusion is, and I hope you guys get a chance to, this paper that I wrote is much too long, but if you can dig into the technical part of it, I came up with an approach that would allow private enterprise to create a system that would provide education in the rural areas and in other unserved areas with optimized for education, incentivized in a way that had no cost to the public, but solved all of the technical problems. And the essence of the incentivization is, first of all, cell sites, that every educational area, and I talk about schools, libraries, has property, and if that property is made available to private enterprise for cell sites, that's a form of incentivization that costs society nothing. The second area is spectrum. The areas that we're talking about, most of them have tons of spectrum. And there is an opportunity for the FCC to figure out a way to make that spectrum available to operators who provide the kind of coverage that's required for education. And the third thing is backhaul, and Mark Bayless pointed out that there are all kinds of forms of access to backhaul that are not being used today. Poles that are set up and are unused because of new technology, and there are ways of providing backhaul in a low-cost way optimized for education. So the suggestion is, first of all, accept the fact that we have a serious social problem and create an environment where private enterprise can come in and solve this problem with appropriate technology. The technology itself, by the way, the RF part of it, is a no-brainer. We have learned a long time ago how to create antenna arrays and base stations that can have much, much greater coverage than existing systems if the emphasis is not on high speed, not on low latency, but on coverage. And so it is possible to get both fixed and mobile coverage at very, very low cost. The objective of this entire proposal is provide the ability to serve students at a cost of less than $5 per month for at least 10 to 20 megahertz, with that number, the speed increasing as time goes on when we need things like virtual reality, and with the cost going down proportionally. So that's just a summary of what this proposal is, and I hope that we can at least start a conversation to make this thing turn out to be real.
Thank you, Marty. And at the bottom of the slide that's up, we collectively decided that solving the digital divide should be a national priority. And with some interest, we noticed that there is discussion of a new rural advisory council. So if there's an opportunity to build on whatever that work is going to be, we would like to understand that as well. And with that, we turn it back over to Brian, who should be now
thanks,
refreshed.
John. So for round two, 20 slides to go. So slide 41, the next area we're going to jump into is IoT, 5G IoT security concerns. And if we move to slide 42, yeah, this is another area I don't think I have to, mention that, is in the news every day. Everybody sees something on 5G security, the importance of 5G security, and the emphasis that's being placed on it. When we look at it, certainly there's a multitude of areas that can be addressed. Spectrum jamming, spoofing, and snipping concerns are one of the things that we think we need to focus on, because society is going to depend even more critically on wireless services. And especially as you move into the 5G IoT era, and the number of IoT devices that are predicted to be out there, we're going to see a lot of things connected wirelessly. So there's going to be a dependency on that wireless connection. Wireless services, like any service, are vulnerable to failure, whether it be malicious action, human error, or acts of nature. And some of the vulnerabilities would include jamming, spoofing, snipping, cyber attacks, misconfiguration, and unintentional interference from both human and natural. And the solutions and mitigations can be put in place, whether it be through laws and regulations, through system and component design, including SDN, software-defined network and programming, and having operating best practices, including behavioral aspects and analysis, as well as market incentives. We move to slide 43. Looking at spectrum spoofing in particular, radio receivers are inherently open to impinging signals in order to operate. So they have unique vulnerabilities, such as spectrum denial attacks. Since these wireless services are increasingly digital, they're also exposed to cybersecurity vulnerabilities. There is disagreement on the importance of spectrum denial attacks relative to cybersecurity attacks up the protocol stack. But the impact could range from simple data collection and monitoring to life safety. If we're looking at healthcare vertical markets, things like insulin pumps, for example, you're certainly looking at life safety issues. And there are local attacks that have the potential to cause detrimental impacts that could potentially enable millions or even billions of device connectivity and new radio cell design. So these potentially detrimental impacts to millions of connected devices due to the new radio density is certainly an area that needs some focus. And if we move to slide 44, the 5G is also looking at adding privacy protection into the standards, one of which is protection against IMSI catchers. So if we look at previous technologies, IMSI catchers was one of the ways that can be used to penetrate the system, and that's because the IMSI was transmitted in the clear. There is privacy protections being put in place on the uplink with a concealed long-term subscription concealed identifier that's being introduced. And this will allow using this temporary identifier as opposed to the IMSI and which did not exist in 4G. So this will allow for some privacy protection of the user. And further investigation is ongoing to other aspects of resiliency to spectrum vulnerabilities. Slide 45. So within the TAC, we are going to survey the relative risks posed by various vulnerabilities and available mitigations, look at the state of the art, identify areas where additional work is needed, and recommend any actions to the Commission. And we're going to be inviting presentations. We have technical research by working group members, as well as group analysis and discussions. Slide 46. This is the area where we kind of overlap with the previous working group, looking at various antennas. And if we look to slide 47, when we look at the densification characteristics, especially as we get up into the millimeter bands, it requires much greater density of new radios to support through and providing greater spectrum reuse. What we see here is the number of antenna elements deployed based on the carrier frequency and the bandwidth that's provided, as well as cell radiuses. And what we find is that these characteristics provide bandwidths on the order of 500 and 600 megahertz per channel. And one of the KPI requirements looking at in the IMT 2020 requirements is to get a cell edge data rate of 100 megabits per second. Next slide, please. So some of the potential barriers to deployment, obviously the millimeter wave deployment could take up to a 2-year cycle. For every cell, the operator needs to gain that site approval and equipment approvals, negotiate fees with the site owner, deploy, provision, and maintain the base station, ensure it has appropriate backhaul and power, and conform to the city's aesthetic and environmental regulations. So that, in itself is one of the things that could slow down the deployment of densified 5G cells. Slide 49. This is our partnership with the Antenna Working Group on issuing a public notice on new radio and antenna design and aesthetics. And again, the intent, as was mentioned, is to reduce barriers to new radio acceptance, as well as address design and install aesthetics. And with that, since we already covered that in the previous presentation, I'll leave it at that. So slide 50, another area we're looking at is IPv6 and a call to action. So slide 51, there's projections that there could be over 20 billion IoT devices in a few years that would really strip IPv4 capacity. IPv4 to support 20 billion devices would require, additional NATs, which would require additional network, which would have additional network latency. So deploying 5G with native IPv6 as the primary protocol and IPv4 support through IPv6 tunnels gives us the ability to support IPv4, but also have the advantages of supporting IPv6. And 5G adoption of IPv6 will put the USA in a leadership role for both IPv6 and 5G deployment and set the standard for the world to follow. If we look at the worldwide, on May 7th, the China Ministry of Industry and Information Technology did look at action and adoption of that. The standards do support IPv6. It's a deployment issue, not a technology issue. It could be leveraged to integrate the user plane into a layer used for forwarding packets to various data paths. And if we look at slide 52, this just gives an overview of IPv6 support from the 2015 to 2017 timeframe. And as you can see, computing platforms were at 100%. Smart TVs and computer printers improved year over year. And the growth of this really shows that the IPv6 deployments are progressing. Slide 53. So Next, we looked at satellite relationship. As I mentioned earlier, 3GPP, one of the work items it has is to study 5G satellite. And if we move to slide 54, we'll note that satellite will continue to be an integral component of the internet. 5G should be put in the context of a balanced roadmap of future wireless technologies. That includes not only millimeter wave, cellular, Wi-Fi networks, but also satellite to complete the broadening demand for new applications. And each of the networks provides unique value to the user management, security, and capabilities, and providing the connection to the global internet. A Cisco report predicts that 5G cellular devices in 2021 will represent only 0.2% of all connected devices in the world and will account to 1.5% of network traffic. Given that the internet traffic is going to exceed 84 exabytes of data, 50% of that will be Wi-Fi, 30% will be fixed, and 20% will be mobile data. Next slide. So slide 55, the satellite industry is launching capacity to meet the demand. New geosynchronous launches will add about 1 terabyte capacity per launch, with 1 scheduled over the U.S. and 2 more to cover the rest of the world, and more will be added to meet the demand. And the projections shown here represent dated estimates based on trends. As satellites, a fast innovating telecom sector, past trends do not necessarily define future capacity. Moving to slide 56. So some new developments, if we look at slide 57, worldwide 5G split. We're seeing, as mentioned, sub-6 gigahertz in some parts of the world versus millimeter wave focus in other parts of the world, and some split in the equipment as a result. We're seeing dedicated spectrum initiatives from various countries, including a dedicated spectrum for industrial IoT. Market projections are up per Ericsson report. GPS spoofing, timing and location impacts is another one that we're going to address. Open RAN has the potential to disrupt RAN services market. Augmented and virtual reality apps and devices are in development. And one hype alert, we need to realize we're still in the early days of 5G. Slide 58, summary and what's next. So slide 59. So in summary, 5G is still in its early days. However, deployment is strong. As we talked about, spectrum management is really critical to the path of 5G success. And that includes both low, mid, and millimeter wave ranges to fit the various needs. There's a number of opportunities related to shared spectrum. Standards are on track. 3GPP Release 17 has many strong proposals. Rapid development and innovation in multiple 5G IoT verticals are going to take advantage of the new 5G service capabilities. The digital divide should be a priority and may require new models, and new security threats are emerging related to spectrum. And there's opportunities to drive industry collaboration related to RAN. Slide 60, please. So what are we going to do in our working group in the third and fourth quarter? We're going to continue to monitor the standards to see how Release 16 progresses, as well as what's going to be in Release 17. We're going to look at IoT vertical impacts, roadblocks, and opportunities. We're going to take a deep dive on C-band and dedicated spectrum. We're going to work the antenna issue with the public notice, working with the antenna working group. And greater investigation on spoofing, jamming, and sniffing issues, as well as the rural area focus, with several key points on antenna design, shared new radio resources, study some of the drivers, such as Marty with the education proposal, 5G secure service alternatives, and review spectrum and backhaul options specific for rural. Look at the verticals and relevance, as well as get input from the FCC and staff. Slide 61, please. And again, we have a number of proposed speakers that we're trying to line up for the third and fourth quarter to talk about these topics. And, we'll be looking to subject matter experts to come in and help educate us on those various topics. So that is the end of the report. Want to thank everybody who contributed and participated to the working group. We have a lot that we've done and a lot to do. So with that, I'll turn it back to you, Dennis.
Very good, Brian. Very good group. This is a marathon. Actually, Michael and I are debating whether this was the longest ever presentation in the tech.
No.
But certainly, and John is pointing to you, Adam. I think this challenges Adam's place at the top of the heap in terms of the number of slides. But it's a very rich topic. It really is a very rich topic, and I really do applaud the group for the amount of information that you've been able to assimilate and present to the group. By itself, it's a huge volume, but also high quality of information, letting us know in so many different dimensions the parameters of this much hyped topic of 5G. I really do thank you. Moving to questions and comments, Ted has had his card up since the early going of the presentation, so Ted, please.
Yeah, I want to push back on a couple things that were given. I think this is really important for us to be very careful and technically accurate, and I think the Commission needs to consider these points. Number one, I want to push back on saying 5G is not for rural. I think I heard that, and I want us to be really, really careful. It's vital. I think 5G is the best thing that could have ever happened to rural, and I'm going to explain that. We saw in this presentation that 5G cells are 100-meter radius in an MMagic study. That's for deep urban core. But when you're in rural and you have a line of sight, you can do with 5G millimeter wave spectrum the same thing you can do with 5G midband spectrum, and the same thing you can do with all the Wi-Fi providers, the cottage industry, that are providing rural Wi-Fi today to tens of millions of homes. And that is, you simply can deploy fixed point-to-point backhaul and replace aging copper with this 28 and 37 and 39 gigahertz licensed spectrum. Now, are carriers going to do that? Well, no, that's obviously not what they want to do. But the FCC has a lot of power, like you did with AT&T's acquisition of DirecTV, when you said as part of that deal you will deploy 10 to 20 million wireless local loop connections to rural America. The fact is the 5G millimeter wave spectrum in particular gives the first protected multi-hundred megahertz pipe that actually can deploy in rural spectrum. So I don't want us to throw 5G under the rug because it's an urban model. The fact is there's a lot of spectrum, and the regulatory efforts by the Commission could actually incentivize carriers to not spend the CapEx on digging up old copper that the rats ate into, but instead could be putting up lampposts or even 60-foot or 100-foot towers on farms where zoning is much less difficult than it is in the urban regions. And the second thing I want to push back on what I heard is the satellite field. Now, the whole fundamental growth of wireless and why cellular works and why 5G I think is great for rural is not just you could do these line of sight hops. And by the way, you got rainfall 10 dB per kilometer, but you can easily take care of that with 10 dB more antenna gain on fixed links at 28 gigahertz. So the FCC Commission rules for fixed point-to-point in rural could actually allow more effective radiated power, and you could overcome any weather, any hail issue, as long as we can get a line of sight with directional arrays. Now, the other thing on satellite is satellite just does not have the capacity that mobile does. And I'm going to invoke Marty Cooper's law that says the whole capacity of cellular is when you shrink the cell and reuse the spectrum. You look at a satellite at 150 or thousands of kilometers above Earth, the illumination of the best antenna that you put up in the sky is going to cover tens or hundreds of kilometers. You get no reuse at all with satellite. So, and the commissioners need to know this, Michael and Eric, because I've heard the commissioners say, oh, satellite's going to do 5G. The fact fact is you're not going to get the capacity or the spectrum reuse from satellite that you're going to get on the ground simply due to Cooper's law. So let's really be careful when we're talking about satellite. It's for very low data rate sensors. It's not going to be replacing what we could do at a terrestrial 5G millimeter wave or broadband at any frequency build out. Those are the 2 points I wanted to make, and I think we need to be careful about that.
Just one point clarification. I didn't say it didn't apply in the rural market. We said that it applies less, and particularly all the investment in millimeter wave and in the high spectrums, we didn't expect to see the benefit in the rural market.
My point, though, is that same investment that's making that equipment can easily be put on a lamp post in rural Iowa and provide 2 or 3 miles of distance. I did an experiment with less than 1 watt of power and showed at 73 gigahertz we went 10 kilometers, even with non-line of sight in rural Virginia. So millimeter wave can work great in rural.
And let me jump in here. This is Russ Jurek on the working group. The shuttle, you put a caveat in there of line of sight.
Absolutely.
Into West Virginia, but West Virginia has real issues with line of sight. Not only that,
but the Wi-Fi industry's been doing this for 10 years. That's how Wi-Fi gets to rural. We can now use bigger license bandwidth with the economy of scale of equipment. I just want us to be sensitive of that.
Well, we'll let Russ
you're still talking about an investment requirement, and we tie the rural issues to, it's a complex environment where it's not just a technical challenge. There is a requirement on the economics of deployment, the requirement for investment, and we have talked to a number of, deployers, not just this year, but last year. It is a real challenge to get that investment, so it's stimulated. It's not as easy as, I agree, there's opportunity.
No, that's where the government steps in. That's where the government says, I know you wouldn't do it unless, no one would build the interstate highway unless the government said we're going to build an interstate highway. That's my point, that the FCC or the Trade Commission can somehow put some incentive to take the economies of scale that the carriers are deploying in urban and use that same equipment and incentivize the carriers. No one's going to do it on their own. That's why there's a cottage industry of Wi-Fi providers. My point is the technology can do it. So let's not throw the technology and the spectrum under the bus. Let's figure out how we can incentivize that tough problem you've correctly cited, the investment. How do we make the behavior of the telecom industry solve this digital divide problem?
Hey, Ted, I really appreciate your comments and input. What I really would like to have you do is join us on the Monday sub-working group.
Yeah, I couldn't make the phone calls work on my schedule. That's why I'm in the
I think it was Thursday you
vehicle.
couldn't make, but we need to double check on the Monday.
Russ will get you scooped
Hey,
in.
Russ and Brian and Ted, it's Nomi. I just want to also just ask a follow-up question about satellite for IoT. I have met with a number of companies, they're startups, albeit, that have interesting use cases that they're looking to solve for IoT with satellite. And they claim that they need very little spectrum. Again, these are just IoT applications. They don't match the ones on your slide, Brian. They're more so things like agriculture, but they're all sensoring and IoT, and they and they need like very little revisit rates from the satellite. And so these companies are, I thought it sounded pretty compelling. Again, I haven't done any technical due diligence on them yet, but I thought they were quite compelling. Does that fit in here at all, just as an IoT, technology solution?
We've talked to a number of the rural community last year as well. You're right. Some of those are really they're a good fit for what we call narrowband IoT because it's low data rates. And so the capability for like a nitrogen sensor or a water sensor in the field is not it's not a high data demand driven requirement. But then when you get to some of the, if you want to move to autonomous farming where you have like John Deere tractors, right now most of those are doing more autonomous driving versus connected driving. So the difference being if you really want to have a connected capability where you're actively steering that maybe through a cloud service or an off-prem service versus everything on board with your LiDAR system on the tractor, that's a different story in terms of the network demand. So it really depends on the actual. So we've got some speakers we plan to bring in. I think one of them, Meryl's working on, is a grain silo operator, just to take a look at what some of the different operator characteristics would be around agriculture. And then there's everything from animal tracking, from the animal industry, farming perspective, which again, some of those may be low data rate. It depends on what kind of data you want to get.
Yeah. Another thing, Russ, and I think that's exactly right, is, there are services that potentially don't require the enhanced mobile broadband, ultra low latency applications. The other thing we should look at is Addis is doing a study and trying to characterize IoT. And, we've already looked at that, had that last year, but they've progressed that work. But yeah, that could help identify cases where some of the low bandwidth, non-latency dependent services could fall into that.
Adam, please, you've been patient here.
Okay. So I think a point and then a question for Ted. I think when you actually look at the millimeter wave technology, again, from my own experience, experiments, and actual deployments, the point-to-point and including a certain amount of vegetation, all of that, the millimeter technology absolutely works, will give you the channels, you'll get the throughput that Ted is talking about. The flip side, and this is really the question, Ted, is if I were to look at what is a rational design of a network for a set of fixed point connections, for the fact that rural areas are not just scattered in a random way, they actually tend to be very linear along roadways, things of that sort, I would say you want the millimeter wave technology, but you may want to have nothing to do with 5G other than sort of taking on some of the technology. And so what I would say is that for a rural problem, in fact, what the FCC ought to be doing is taking a look at what is the basket of options that's available, mixture of fiber where you can do it, relays where you can do it, to end up with a rational architecture that fits the setting, and not necessarily put it all under the 5G label where it doesn't belong. Okay? I don't know whether you agree with that or not, but I think that may be a much better alternative.
Well, my point was simply to say this, that in rural America, there's usually a fiber optic cable somewhere along an interstate or along a
good
train
place
track
to jump off
and,
of.
and there's jumping off places.
Yep.
And it'd be good to have an inventory of where that exists to be able to jump off legitimately. And we tried to do that in Virginia back 10 years ago. And once you have that inventory, you do need to do a study.
And do the middle mile layouts, which gives you more
that
jumping
work
off
needs
points
to be
so
done.
you can do it.
And I'm saying don't throw a technology under the bus yet until you do that, because the only way rural...
But millimeter waves is not synonymous with 5G is the whole point.
Yeah, that's my point.
And you shouldn't, attach
That's my
the
point.
two.
But the equipment will be built. The
Absolutely.
3GPP is looking at the in-band backhaul,
It will
so it will
make-
be part of the infrastructure.
The
So it's
technology will be
being
much
built in, and so that could be a real value to the 5G, 3GPP infrastructure that carriers are going to be deploying. And that in-band backhaul could be actually a big saving grace to go from that fiber optic cable into rural America.
Well, no, to in fact sort of make this practical and affordable, you want to scour and use that technology as much as possible.
I think you guys are...
But
Hey, by the way,
overall,
guys,
I think the architecture still ends up being very different.
Unfortunately, we left 2 slides on the editing floor where we had input from T-Mobile, very focused on their planned deployment for rural with low band. So we are not writing off at all 5G. You know, in fact, T-Mobile has plans specifically that I don't have the slides right in front of me, but unfortunately, we had a very long presentation, obviously. By the way, Adam, you still hold the record. I think yours was 85 slides last time.
No,
I don't
I
wanna
think
take
I
the
gave
crown
it up
from
on this.
Yeah,
It's in the
no,
Guinness
I don't
we're
wanna
not
take
talking about number of slides, we're talking about actual time, elapsed time. so-
Okay.
Can we submit this to Guinness, or?
We did reduce, and we can share those slides with the rest of the group because they were good slides on coverage and what T-Mobile's plans were in terms of rural with low band. So
Okay.
there is an option there. It's still a very complex problem. I think it's a great discussion here. Would love to take this opportunity to recruit some meetings to our sub-working group, talk to John. He's there in the room.
Russ is our number one recruiter, especially for those of you who are new to the TAC. You know.
We're gonna have to go to 2 slides on members, but that's cool.
Okay,
Anyway,
very good.
I really love this discussion, and don't mess with the Godfather.
Okay, Marty has his,
Ted, we do have one area of disagreement. We do agree about satellites. We do agree that coverage is a real issue. But if you can, with 5G and existing equipment, achieve the cost objective, which is really low cost, much lower, without any public taxation involved, and provide wireless coverage over wide areas, not Wi-Fi in isolated places, I would go along with that 100%. You just have perhaps neglected the issue of economies of specialization versus economies of scale, because I believe that there's a lot of baggage that goes along with 5G that is unnecessary for education. So you could, but if in fact it is true that you can have very low-cost 5G equipment that does wireless coverage, be my guest.
and I would invite you, Marty, and you, Ted, to enjoy lunch together to continue this conversation.
As long as you buy.
Well, actually, Kevin has bought, and Nokia has procured our lunch for us. But we do have Steve's card up. You have the last remaining card, Steve.
Okay, thank you.
Oh, no, you, Travis is up, okay.
So, of course, I can't resist to respond some to the satellite critique. One is that at the end of the day, what matters is the cost per bit of delivery for coverage. And the ways in which you get there, I like talking about, hey, satellite doesn't have spectrum reuse capabilities the way 5G does, is kind of missing, is looking at one small technical part of it and not looking at the overall end. And I think that at the end, that what matters is how much is it going to cost to get it there. I'm also a little resistant at the idea of making requirements for 5G deployments, because that actually represents a hidden tax and one that then gets spread out. And I don't think you're taking full advantage of the diversity of technologies and those solutions when you were, in my mind, implicitly suggesting that 5G can just do it all if it was just required to do it all.
I think you get to have lunch with Marty and Ted. But this is actually, I will take a moment. This is actually why we're together, for these kinds of discussions. If we all were of one mind on everything, this would actually be largely a waste of time and energy. But these engagements and debates, rigorously held views, are really what this is all about. And I'm quite delighted with this, and quite delighted with the presentation as well. Travis.
So I'll switch the conversation away from spectrum to some degree. So I wanted to add a comment. When we talk about 5G, and there were some slides there that showed 5G deployment, I think it's really important to understand when we delineate between 3GPP compliant, non-3GPP compliant, what exactly does that mean? And what does it mean with release 15, release 16, release 17? I didn't see deployment models that were up there. And so for clarification, in 3GPP, we did define about a dozen different deployment models for 5G. In Release 15, what we focused on there was radio over 4G network core. And so what we see out there today in 3GPP compliant deployments, it's 5G radio running on existing 4G core. And that's important because one of the things that we defined in 33501 in the SA3 was the hiding of the IMSI, for example, that you saw here, the use of suki, soupy, sushi for lunch. That only applies in what we call standalone 5G, where you have a full 5G core network that's fully defined. We're not there yet, by the way. We're late. We're behind in defining all of the functions in the network core for 5G. And so we're still a few years away from fully defining that 5G core so that we can have a true standalone 5G network that doesn't rely on all of the authentication and authorization of 4G networks. So just a point of clarification. In some of the international deployments that you saw where they stated they had full 5G deployment, that's proprietary. That's not standard.
Great. Thank you, Travis. And thank
I have a feeling listening to this, sometimes we're letting the perfect be the enemy of the good here, and I think we need to really be careful about that. Well, I've said it.
Right.
Perfect can be the enemy of the good.
I just briefly, and it follows up on the last comment, was NFV didn't really appear here. A lot of folks, until recently at least, have tended to talk about NFV as the reinvention of the core for 5G. NFV is actually getting out into 4G networks to some degree, but I'm just actually really asking, is it the plan to include that in the SWORT item? Or, you've got a lot on your plate, so it's just a question, it's not even a suggestion.
There's actually been sort of a reversal within industry around NFV. We're going to see service providers are now pushing away from the table, and you're seeing more virtualization, whether it's Kubernetes containers or VMware. So there's been a trend within industry to get away from NFV because I think the industry's realized it's too complex and it's too costly for us to actually make it work.
Representing VMware, this is David, yeah.
By the way, we do support NFV, it's just over
Yeah.
our staff.
Yeah. All right, and with that,
We're making NFV work.
Yeah.
As are we.
with that, the cards are down. We are a bit behind, but again, this is very rich, both input of information and very rich conversation. We do have the dedicated lunch that's been established for a few of you. Again, recognize Kevin and Nokia, Kevin Sparks and Nokia, for providing our food. Food is over on my right. Please avail yourself of the food. We will come back at our scheduled time, so you have 15 minutes less of lunch, but you've enjoyed the meal that we've had on 5G and IoT in its stead, and I think 45 minutes is probably enough for lunch in any event. So please enjoy lunch. Second half of our session. And thank you again, Kevin, and thank you, Nokia, for, yes, appreciate that. All right, we're now moving into the artificial intelligence component of our session, and there's nothing artificial about the intelligence of the people who will be presenting, so Lisa and Adam, take it away.
So I'll start with a couple of opening comments. Just to be lighthearted,
I did go back and look at last year's presentation, and I think it still holds the record of 89 slides. Although, in our defense, much of it was in backup, but it's still, I think it broke the email server when we tried to ship it last year.
Confession is good for the soul.
Exactly. So just a few opening comments about this group, artificial intelligence. It seems like a very broad topic, but I was thinking about, last year we had an even broader topic, which is computational power and stress on the network, which, we covered a variety of topics. Artificial intelligence and machine learning was one, and this was last year. Virtual, VR, AR, cloud, fog, and edge computing, and data sciences. And out of that work, we came out with some recommendations, a lot of reference data and education. And the commission wanted this group to now focus on artificial intelligence as a specific drill down from the work we did last year. So our challenge this year now is to take artificial intelligence, which is an admittedly quite broad topic, and narrow that down to what we want to continue to do. And I suspect in 2020 we'll even be more focused, but in the general same area. So with that, Adam, I'll turn that over to you to take the next few slides.
Okay. So I think, first of all, in terms of the working group, I think you have the names up there. If you have any interest and would like to join this group, let us know. I think we can always use a lot more help. So I think what would be useful to do is take a little bit of a look at the charter. I think, as Lisa already said, the focus is still sort of computing, but with a focus on the things associated with artificial intelligence. So we're tasked with providing information on AI and a variety of roles it might play in the communications network and services. Where is it being employed in the network today? How will it be developed? What are the benefits and risks associated with it? Again, taking a look at the rules that the Commission has in terms of its policies, barriers to introduction of AI, things along those lines, and where might the FCC introduce AI in its own systems. I think the way the charter was written, it says AI is a relatively new field. I would sort of personally sort of take issue with that. There are a lot of precursors to that that have been around for a while. There's also public perception of what AI is that might, I would say, be a little bit at odds with reality. Because AI is not at a level that a lot of folks in the public expect it to be at this point. But I think we have some degree of flexibility in terms of what we actually cover. So I would say, if I look at the charter, part of it this year, since we have a short year, is really to lay up the hard work that I think has to be done in detail next year. Okay. I thought on the next item, I thought what would probably be useful, and I don't mean that I'm by myself, but I think talking to Lisa, several other people, is to sort of help guide the context of what is of interest to the FCC. And we thought that taking a look at the titles of the Communication Acts is a good guide to what the FCC really has in its charter, and to then maybe address some things which are not in the charter today, but are sort of the begging issues of what AI might introduce. So I'm not going to go through and read those, but I think those are also fairly important. And then when I look at that as the setting, I think AI plays a role in the titles, and it can be anything from enforcement, how the technology can be used to actually understand the underlying facts, patterns, and behaviors, and to sort of use that as selection of focus for future missions. Okay?
Adam, can you flip the slides as well as you go?
This one?
Slides.
I didn't change the slide. Okay, good. I have that up there. Good. Okay. So if I take a look at examples, Section 706, for example, looks at advanced telecommunications incentives. Okay, we just talked about rural in the previous discussion. Well, how can AI technology actually be used to help execute on a mission of that sort? Okay, insecure devices, robocalling prevention. Really quite a few examples you can think of where AI may actually be tied to something that the FCC does and help it with its mission. Okay.
I think over to me.
Yep. Let me turn it over to you and see whether you can take the next part forward.
So looking at this topic, we sat back and looked at how do we really focus our working group on what is relevant. So we came up with 3 buckets that we want to group the work into. And the first one being impact on the network itself. So that's automated management for traffic. So can we have more real-time and more intelligence around understanding spare capacity and how to leverage it, network orchestration and slicing, real-time fault detection and repair using AI, which could be pretty compelling, and especially security response. So, these are just 3 topics that instantly would come to mind, but we'll be diving deep into that area as well. So the second bucket is to look at the areas of industry and where there's high impact. So some examples that we learned, and came across last year, and actually had some speakers on, were financial, healthcare, agriculture. We think there's a lot of work we could do with education, legal, and a lot of manufacturing, industrial control type work. And I'll also say we've got a lot of synergy with the 5G and IoT team as well. So quite often we're working with them, and they're providing a lot of helpful suggestions that are much more specific to AI with our group. We want to look at things such as, what does the impact on the network architecture look like if we had these technologies and we applied AI to it? Would that drive more edge compute? Would that drive more density in the core? Whatever that might be. The load on the network, and also the economic and societal impact. So we're considering that as an aspect of our prioritization as well.
Hey, Lisa, I think we're 1 slide behind.
Oh, we keep forgetting, don't we? Mine is advanced, so I don't know why you guys can't see it. I need AI to advance my slides. It should know that. So, and the final bucket, and this one I think we'll be able to get much more specific on, I'm hoping this year, is how can the FCC use AI to improve and to be more effective with internal activities, such as, here's just some examples. We haven't studied it yet, so we may come up with quite a few others. But what is the legal viewpoint combined with economic impact, or the ease of access for the public? So, for example, can AI help the public get quicker access to documents, or can that make it more clear? Or can we mechanize the enforcement of regulations? Rather than having human intervention to do this, maybe we have AI as a component. So for the execution plan, what we plan to do is identify high-impact applications for AI relative to the FCC mission. And from that, in our first month, we've gone down a lot of different trails. And our big focus is that we stay on target with things that impact the FCC mission. You could go almost anywhere with AI. And so I think, and that's an important thing we keep coming back to. And our strategy is to learn from the experts. So we want a general understanding of AI. We want to invite some experts that understand the overall view and educate the team and set a really good foundation. I think a lot of these, we might find some in the institution area. And in industry, we'll be recruiting speakers from industries with large-scale AI and folks that have knowledge of using AI for your network automation and architecture. And I know we've got Stephen Hayes, I know you're going to look for someone for us at Ericsson that focuses on that. And we've got several others that we're pursuing right now. and FCC applications. So can we understand how it can optimize the workflow? And we've got some great members, FCC liaisons, to work with us on that, and they're helping provide a lot of guidance. So where are we headed with this? Because, you know, as I've mentioned before, we could end up in a rat hole pretty easily. So we're identifying where we think we're going by the time we finish this year, and keep in mind this is a short year. So we want to provide education for the Commission, understand the impact on the fundamental network structure and how it impacts the mission. So this is just pure education to the FCC. We also want to define a continuance of this mission into 2020. So I anticipate, you know, as we started with CPSN, we narrowed to AI. I expect we're going to narrow even further and then go deeper in 2020 with this team. And the final is to, you know, as everyone loves, we want to develop actionable recommendations. And here's a couple of examples. Obviously, we don't have the specific ones yet, but these are examples of what we might target. So how can we use AI within the process of the FCC to make regulations more accessible? And how do we identify where the current regulatory structure is called into question because of AI? So specifically, you know, as you write new rules, how do you look back into the old rules and make sure that you haven't created a conflict or confusion? That might be one example. So that's our strategy. And Adam, I'll just let you go to the next slide.
Okay, and I think in doing this, we are taking a fairly broad view of what AI is. I have a figure up there. You know, I think we had a discussion within the group on how you can modify the figure, all of that. Did a little bit of homework. And it sort of mixes things in a way, but it does so because this is really sort of the communities that have grown up around AI. And when somebody says, I'm going to use AI, it's very hard to know what it is that they actually mean. I think as part of the educational mission here is to actually expose the various uses of AI, how they can be applied. And I think it's also fairly important to get a feeling for how AI is evolving. I think there are two very, very good articles. One was done by Michael Porter in Harvard Business Review, fairly lengthy article done a year ago. And I think it sort of looks at the impacts that AI is likely to have as part of digitization, because it ends up being sort of the place where the value of what you're doing from digitization actually gets expressed. I think the next thing is when you start looking at various aspects of this, I think it's just as important, again, as part of that educational mission, to also sort of ferret out all the places where AI is already fairly deeply deployed. Okay? And I don't know how many of you, for example, have a smart speaker, okay? Which does some of this natural language translation, understanding, sends stuff off to the cloud, actually generates traffic, okay? It can have a low-level conversation with you, okay? That's fairly deeply deployed at this point, okay? And there are very many examples of where many of these technologies are already in place. And so part of the mission is also to understand what has already been done, as I would say, indicative examples. But I think after going through all of this broad stuff, it's fairly important to figure out how do we actually create a little bit of a funnel where you can select where the focus ought to be. So I'm going to turn it over to Lisa and have her walk us through that.
Okay, great. So we've spent our first month together. I guess we've had about a month, and the team has done a lot of brainstorming on what potential applications might there be. So our strategy's been, let's not try to go focused yet. Let's brainstorm and make sure we're not missing key areas. And so through that work, we've come up with a variety of different applications. I've got several on the following slides. We're not going to read every one of them to you, but when we finish our piece of the presentation, we open for questions. I'd really love it if anyone else had some ideas on potential applications. If if we could bring that up, or we could talk about it later, or you could send me a note. But we're looking to capture those. But we found they fit in generally 5 categories here, and one being network applications. I mentioned that earlier. Things like bad actor prevention. The network can detect and then correct in a much more efficient way. Societal applications. We have some examples later. And we have a general use bucket for things that don't fit in the other ones. And then, of course, the FCC internal applications. So our methodology will be that
Lisa, if I could add one,
yes, please.
One thing to this.
I can't get the answer to that on Apple Watch.
That's misuse of AI. Yeah.
We planned that.
That was.
Was that yours?
All right, that was good. Okay, but in any case, so the one thing Lisa didn't have up there, but I think it's sort of important. AI can also be used as a tool to do bad things. There's a dark side to it, and if I look at phenomena that the FCC has encountered, stealth of cell phones, robocalling. There are many things right now, I would say, sort of on the fake news stuff, and that's one of the titles that the FCC has some responsibility for. When you look at that, that's another item that one has to watch, and again, as part of the educational things, what are the things that might happen that you really do have to watch out for, okay? Because if you start looking at security, the folks on the dark side of that use some of these AI tools to do some fairly pernicious things at this point in time. Okay?
So the filters we're looking to apply to it, these are preliminary. Our group still needs to do some discussion on that. Would include what is the network impact of these applications. So, for example, if there were an application that didn't really impact the network much, we wouldn't prioritize that. But if it might have heavy impact on the network or change the architectures dramatically, that would be something we would delve deeper into. Likewise, economic impact or societal impact would be some filters that we would use. So let's look at examples of some of these applications. So for the network, for example, so customer experience might be a key piece. What if we used algorithms to predict the network demand to help QoS, particularly QoE, quality of experience, or machine-driven policy management? And I'm not going to read all these, of course, but can we make the network more efficient? An interesting one is, can we use AI to help in wireless design and maximize the coverage and performance so that it's not a manual process? We definitely want to understand the impact of AI on network architecture and also include compute as a piece of that, because edge compute is emerging as a key thing. We already knew that, but we really delved into it last year. And those are some of the examples. Adam, you want to go through maybe the next couple of slides?
Sure. If you have that, good.
I already did it. Go back.
Go back? Okay, got it. Okay, so I think, again, from a couple of meetings that we have had, one of the big items that came up almost repetitively is the application of AI techniques to spectrum sharing, spectrum efficiency, enforcement in terms of usage or interference. If I look at very specifically CBRS, whether you could, in fact, create dynamic capabilities and use and reuse of that. Again, the enforcement issue with interference. Take a look at economic models of exclusive versus non-exclusive use. And then application to policy issues, learning from enforcement and regulations, efficient comparison of new rules and their effect on old rules, How much of that can you actually search through and understand? And then a very simple one. If you were to go to the FCC website today, try to navigate it to find something, pretty tough, okay? Modern, public-facing agency, how can you use this as a technology to improve things? The next one is on the bad side, nefarious side of things like spoofing, robocalling, GPS spoofing, security, privacy protection. There are AI applications both on the defense side and on the offensive side that make a difference here. Okay. And then, just sort of in general, these are the kind of things that create demand. Industrial IoT, smart factories, you hear a lot about Industry 4.0, chip development, smart farming, safety, lots and lots of uses. And to be able to exercise those, you really need the architecture and design of networks that can actually support the traffic patterns that'll emerge. And I think sort of going in a theme from last year, we found a lot of intertwining between usage and how the networks ought to be effectively designed. In some ways, listening to the previous talk on 5G, we seem to be wittingly or unwittingly moving towards a regime where you have a limited number of special networks. Everything runs over a public network and a public infrastructure. And the question is that the best way of actually supporting the needs that will emerge from new technologies like AI? I would say software technologies for finding anomalies, and then lastly, sort of in the computational area itself. Okay. On the societal side, if I look at it, the FCC has taken on projects to look at broadband availability. If I were in a private setting trying to understand the market, I would probably have my folks develop a web crawler that gathers data from all over the place, crunches on it, use a lot of AI tools to actually help me understand what I'm facing. And one of the questions is, does the FCC ever think of doing things along those lines, okay, to better be able to carry out its mission? And I think some of the AI techniques that are available and some of the learning techniques in particular, I think could help out with that. Same thing with emergency services. And then I think it's a lot of public debate on this. Is rule-based systems, AI systems themselves, is how do you prevent introducing bias into the way that those actually function. And then I would say if you start looking at data, knowledge that's disseminated, how do you tag it with the right provenance so you know that it's accurate and correct, essentially. I think while we had a good I would say working group on cell phone theft, I think this is another area in which, looking at the data, there are lots of techniques that can help you to actually figure out who the actors are, how to trace stuff better, and things along those lines. Okay?
So as you can see, there's a lot that we've already come up with that we could go down and explore. And so that's why it's really important to filter it and really look at the highest impact applications so that we stay focused.
Yeah. And it's sort of a list of apples and mangoes at this point, fairly mixed. But one of the things we would really like to do from the rest of the TAC is any other suggestions for things that we ought to be looking at before we start going narrow, really sort of paint a complete picture first. Okay, and then start sorting through it. And I think if you join the discussions, we will sort of continue to still build this a little bit. And then the next part is really a discussion of what should be the metrics by which one constructs that funnel and make sure that it supports the FCC's missions in an appropriate way. and really has an impact overall. I can tell you it's an exciting technology area. Having done a scan for some other activities that I'm involved in, I'm actually sort of surprised at how much deployment there actually is. I would say the pattern is that a lot of the deployment that's successful is in niche areas, as opposed to sort of large organizations that are making a real, that have a good, steady growing business out of it. But what is interesting is that for the larger outfits, again, taken from a set of surveys, what I've seen on AI technology is an incredible number of pilots, okay, and a lot of barriers to actually doing full-scale deployments, okay? And that is because larger organizations need, I would say, dependable revenue streams, things along those lines. There is a risk associated in putting out something wholesale, okay? Flip side is there are major players, I'd say all of the FANGs, some of them around the table, who use these kind of techniques in their day-to-day operations, and it is what makes them successful, essentially, okay? So we're looking for experts and speakers, again, sort of from a fairly broad set of settings that can inform us, and hopefully we have a compelling product for the commission at the end. Okay?
I think your use of the funnel is a very good one, because that's certainly what you've described, and you're still at the top of the funnel trying to get a lot of things in as you go through that distillation process. Satish was the first one up, so please.
Well, to wake everyone up, I wanted to say, what is the difference between AI and machine learning?
So, okay, let me take that on. If I were to...
Let me give the answer first, Adam, and it's a joke, okay?
That's good.
If you're working in PowerPoint, it's AI. If you're working in Python, it's machine learning. Okay, so that's just a joke. But the whole idea behind that is to say, for a long time, there has been a focus from the software industry to develop software for AI. And it's really, in my view, the wrong approach. You really start by looking at what outcomes you want to create. And I think to your point of niche areas where people have successfully deployed this or actively doing pilots, it's where people are clear on what is that outcome of automation that they want to get. And that's where AI is becoming successful. The one other thought I had on barriers, I don't know if you considered this, is from an education perspective. Because when we talk about AI engineers, there's clearly a war on talent going on, and so it's hard to get the right talent. But when we went to the schools and tried to recruit people with the right software skills, we asked them, and everybody's got this AI neural network in their resume. You ask them, what did you actually do for your projects? It's separating dogs and cats, right? So it's a static picture of a dog and a cat, and your senior project is how do you separate, can you tell the difference? Mm-hmm. So I think, but when you start doing more serious things, it's not just about static things, it's about things that are dynamic. And so it's not just about a software skill, but it's merging a software skill with, let's call it an economic skill, or a software skill with a human skill. So I think there's some shifts going on, and I know Stanford University has just launched this human intelligence program, which I think is a step in the right direction. So yeah. I'm looking forward to working in your group.
We are too. More than welcome. And if you have suggestions for speakers who can be informative on this, absolutely love it. Okay?
I'll send it your way.
Yeah. Let me maybe add a couple of things, and I would say it's a little bit of a surprise to me. Okay. For, again, another project, I just did a fairly hard look at, number one, what is happening in AI hardware. Okay? And it was fairly easy to find somewhere north of 60 outfits that are startups, okay, that have probably taken down somewhere between $2 to $3 billion in the last 2 years. So tremendous explosion. And then when you look at all of the major players, so if I look at major processor players, whether it's AMD, whether it's Intel, whether it's ARM, every one of them is doing its own processor, both for MI and ML as a specialty. If I then take a look at the NVIDIAs of the world, the Samsungs, Google, Apple, et cetera, okay, you end up with another 50 large corporations that are all investing fairly heavily in turning out silicon, okay? And I got to say, I find it very surprising that you have this level of investment, okay, in such, because not all of this is going to survive.
Never does, never does.
Never does, okay? So that's one part. If you now turn to the software part of it, okay, the number goes out by another factor of 10, easily, of very solid things in this space. If you then ask for large-scale successes, deployments, all of that, those are still few and far in between, okay? There are some things that are institutionalized, okay? And the thing I want to get across is, when you brought out ML and what's the difference with AI, it really doesn't matter that much because in the end, this is a systems game. You use all the tools that are available to you, no matter what the label is, okay, because you care about the outcome, okay? Okay, there is one other part that comes through though, okay, and I think David provided us with this last year. And that is, the source for all of this is you have to generate data somewhere, whether it's from sensors, whether it's from other information, it has to be collected. That generates traffic. There are things that are done close to where a device might work, where you may be on a factory floor. And what you find is that's more real-time, control systems oriented. Okay, if you happen to be running 19 assembly plants and they all have some things that you're measuring, you aggregate the data somewhere. That helps you make decisions. There's a lot of AI involved in that. Eventually goes to the cloud. A lot of the learning stuff gets in there. Those learnings go into lower level models, okay? And what you find is that quite often we get stuck on thinking, hey, what's the traffic generated at that very end, okay? Well, it may be that that very end causes an order to 2 orders of magnitude more traffic elsewhere as a consequence. Okay? Question is, how is that data reused? What's the governance for? There are lots of meaty things built around this. Okay? And I think participation from all of you is fairly important. Okay? Because I think it will impact the FCC in some fairly fundamental ways. Okay? I'd say the last thing to say is, if you actually look at the legal profession and you look at the outfits that make money supplying things to lawyers, okay? I look at LexisNexis as an example, okay? There's an incredible number of AI tools built into their kit. Everything from doing intelligent searches, actually doing logic of arguments. I mean, a tremendous amount of stuff, looking at rules in an automated way, okay? And, what it reminds me of is, somewhere in the past, the suit between IBM and CDC, Control Data Corporation, where one of the players said, well, here's the data you asked for, it's a truck full, okay? Well, they built a knowledge system that was able to actually reduce that and produce results in a real short time, okay? This stuff has been around. It's really very powerful. I don't see that kind of mechanisms being, I would say, institutionalized in a place like the FCC at this point, okay? And there are other agencies that are actually starting to do that, okay? So I think,
Thank you.
Great question, thank you. Okay.
Art, actually, I love it that 2 of our new members are the first 2 with questions.
Yeah.
Thank you both.
Yeah, thanks. I just wanted to offer
maybe a suggestion in the realm of network applications that might be a focus area. And I would definitely echo Satish's comments around outcome-based focus. One of the areas that we've seen real early success beyond proof of concept is in the area of predictive analytics, being able to take streaming telemetry techniques to ingest a massive amount of information from the network, predict proactively failures, whether it be optics light levels, being able to replace optics in advance of failures to prevent network outages and those sorts of issues. But we've actually seen that to carry a lot of weight and a lot of benefit in the network. Very early application for us. A lot of others that we're looking at from a quality of service customer-facing standpoint. But in terms of being able to manage the network in a much more proactive, less polling SNMP sort of style and more ingest data, proactively work through what's going to happen. And even from a centralized SDN control, being able to optimize traffic patterns based on historical views has been a real area of focus that's been successful for us.
Thank you.
Yep. Good. Great. Steve, I think you were next up. We should never have two Steves sitting there.
I wanted to bring up AI with a concrete example, part of it going back to 5G, but also is the ability to really mitigate the load on the network. So if you think in terms of medical devices, which was named as something that would load the network up with lots of data, I question that in the sense that AI is currently deployed in smart loop systems for diabetes with passive glucose monitors being connected to smartphones, being connected to insulin pumps, and all by Bluetooth, local network. That data doesn't need to go anywhere.
Yep.
As a matter of fact, you probably don't want that data going anywhere, except when you would push it, not automated. And so but that sort of expands out, like in UAS, if you have autonomous stuff that's flying by itself, that it doesn't need to communicate all the time. So there's the benefit of AI being deployed at the edge to totally reduce the load on the network.
Absolutely. Yeah. No, I mean, in fact, I think we walked through an example last year. If you look at video cameras, they all now have cards that do image extraction, things of that sort. So what you pass over the network is a lot less than what you're actually capturing in the video. Just as an example. Right. So absolutely. Okay. But at the same time, I think it's harder to get your arms around. What you find the medical community doing is collecting data from many, many different patients and comparing the measurements to actual outcomes, okay? And for some things, that's actually done on a fairly continuous basis.
The reason I chose the diabetes thing is that is pretty much a real-time basis, but mostly autonomous.
Yeah.
And the additional thing I would throw in there is that too much insulin is deadly, so you don't really want to open an attack vector by having that COM port always open.
Yep.
I think this is where these discussions become critical. I mentioned it's not only the load on the network, but also how does it impact network architecture, which was a lot of the findings we found last year was architectures will change, and I'll call it loosely, edge compute will be embedded out on the outer parts of the network to mitigate that.
Great.
You may recall some years ago we talked about sharing by frequency sharing by going to a database and being assigned a frequency so that multiple people could use that frequency. It might be interesting to see how AI could dynamically help people share that frequency. I think you mentioned sharing on there, but I'm moving more toward the dynamic sharing.
We actually had dynamic sharing on there. But yes.
Very FCC.
Can I just mention a major DARPA program that's been running on exactly that question of using yes, the Spectrum Collaboration Challenge. So stay tuned for esports for the Spectrum, very exciting event at Mobile World Congress LA this fall, where the Grand Championship will be held.
So could we ask you one thing? I think I talked to Dennis. Is could you get Paul to come and speak to us? We would actually love that.
I can work on that.
Okay, great.
And absent Paul, actually, John has been part of that team, so
That's why we
John
asked.
himself really knows this area very, very well. Yeah, this is Julie. Go ahead, Dale.
I think you're signed up to speak now, if you will.
I know I sound like a broken record, and I will again, but with... Now, how do I deal with that? Here I am trying to be really thoughtful.
That's what college kids today would say.
Yeah. And David's just a college kid at heart anyway.
You know, I've been worried about enforcement, FCC enforcement, for a long time. We talked a little bit about jamming and spoofing, and we have lots of man-made interference sources like collections of LED devices and so forth. And it's pretty clear to me that the FCC, under its current, other people have said this, under its current constraints resource-wise, just can't do the job that needs to be done in enforcement. Yep. And I think it means that we have no choice but try to automate the enforcement process. And just as a reminder, here again, a broken record, there are 6 steps in enforcement. First, you have to detect that there is interference occurring. You need to classify it, identify it, you know, what sort of interference this is. You need to locate it. You need to report it to somebody. Then you need to mitigate it. I mean, you know, something's going to interfere with, you need to fix it. And then the last step, of course, is you need to try to find somebody or put them in jail or whatever is appropriate for having caused the interference. And I'm sure don't have expertise in AI, but if I look at that, it seems to me there's AI applications in all six of those steps.
Absolutely.
Travis.
I was just going to comment, you know, one of the challenges that we have in security, especially as we get higher up into the protocol stack, the attacks that we're seeing have become so sophisticated that industry has had to move away from our standard, you know, monitoring of with static KPIs. They just don't work anymore. And so you'll find there's some good implementations already of both machine learning and AI in the security arena and at the network level. Yep. There's work going on in GSMA that we're doing now where we're taking multiple protocols, applying machine learning. The next step then is to then apply AI so that you can actually do something about it, right? You had robocalling up there. I think that's a perfect place to home in on because, number one, it's a hot topic, right? We all hate robocalling. But AI is a good example of where we can not only apply the machine learning, but also the call treatment. And now that operators have clearance to do that, I think that's an excellent example where we can demonstrate how AI can be a great advantage because without AI, it's going to be extremely difficult to stop robocalling.
All right, I don't see any more tent cards around the table. Any questions or comments from those on the phone lines? Hearing none, we will conclude, and I am really impressed, almost precisely on your
1:45.
time. Well done.
By the way, the smallest number of view graphs we've used.
Yes, the largest
Well, that you've
and
ever
smallest.
used. This is Lisa's influence on you, Adam.
Just regressing to the mean. It always happens.
All right, let's move on into our final working group, our UAS.
Sure. So this working group is Communication Strategies for Unmanned Aircraft Systems, or UAS. And I will introduce you to the work that we are getting going on for the 2019 year. So we have only a limited number of names listed here. These are folks who have already participated so far this year. We have a much longer list of names who participated last year and who I fully anticipate will be joining in to the work of the group. As with the AI group, we've only been getting going over the last month or so. We anticipate breaking up into subgroups, but we haven't done that yet. So we are currently meeting as a committee of the whole. The next several slides are repeats of ones that those of you who watched our work last year will have seen already. These are the topics that we were asked to work on. At the high level, we were asked to study the spectrum issues for UAS, and then with a number of specific questions relating to various aspects of the FCC's interest. Which frequency bands are available and are they sufficient? Which activities can be carried out using existing systems or services? And issues of harmful interference, loss of communications, and radar, and so on. As I think is always the case with the FCC Charter to Attack Working Group, they gave us far more questions than we could possibly address and encouraged us to prioritize them. So some of the other things that they asked us to look at that we haven't had a chance to get onto our work list yet include things like station ID. Actually, we're looking to get to that this year. Radio certification, testing facilities, and other issues. So last year, in 2018, we chose to focus on terrestrial mobile bands and systems, and we deferred to 2019 things like satellite and unlicensed. Coming out of last year, we made some specific recommendations, and I'm putting these up because some of the items in our work plan for this year grow straight out of last year's recommendations. So recommendation number one had to do with how the FCC should go about considering UAV access to terrestrial mobile bands. And we identified three specific tasks within that, one of which is to consider issues of potential in-band and out-of-band interference, enforcement challenges, and what harm claim thresholds to apply. That one is a key work item for us going forward this year, along with collecting data and reassessing service rules. Our second major recommendation was looking at 3GPP technology and noting that it did appear to satisfy the expected communications requirements for low altitude UAVs. And within that, we identified some specific areas. And one particular area, B here, reassessed the technical basis for prohibiting use of certain terrestrial mobile bands above ground level, continues to be of very high interest to the group and will be investigated this year. So here's a summary of what we've gotten started on in 2019. We noted that many of the things that we were looking at and that we believe the FCC needs to pay attention to are going to depend in the end on effective RF analysis tools and techniques for the interaction of these large numbers of low altitude systems. So we have one sub-working group queued up on that topic. We have another one that continues the spectrum requirements work from last year. And then that issue on aeronautical restrictions on terrestrial mobile licenses appears to draw from both areas of endeavor of work, both working groups. Finally, we decided to formalize our work on providing the FCC information on various topics, although that won't be a separate sub-working group. In terms of the RF analysis tools and methods, we do believe that effective policymaking regarding UAS spectrum capacity and requirements, the FCC's highest #1 goal to us, is going to depend on identifying or creating appropriate analytic tools. Those tools need to apply both to non-aviation bands like the terrestrial mobile ones, but also to the aviation bands. They need to apply to unlicensed as well as terrestrial mobile, and need to consider both air-to-ground and ground-to-air, in particular aggregate effects. So there's a great interest in the group at actually tackling this problem this year and seeing what input we can provide to the FCC regarding how you would do analysis of link analysis, coverage analysis, capacity analysis, in-band interference analysis, out-of-band interference analysis. How can you assess predictability where that's required for command and control? A lot of the new technology that we've been hearing about from the other group, like the advanced antennas and new filters that we heard about from previous couple of years of TAC work, all of this is going to impact these analyses and we need to figure out how to pull it in. We did feel that the UAV market in particular, the high volume part of it, is very sensitive to size, weight, and power, and very sensitive to cost. So there may be certain of these technologies that would have a significant impact in other market sectors, but might be substantially delayed before they reach the UAS sector. And so that market development side of that becomes important when you start considering the spectrum impacts of these new technologies. This last point, impact of operation at different altitudes, seems to be an issue that keeps coming up when you start looking at even the difference between a 100-foot altitude UAV and a 400-foot altitude UAV. They're going to have different interactions with systems on the ground and require different methods to predict what the spectrum impact will be and the interference and so on. The other major area we've identified, the spectrum requirements area, we would like to continue our 2018 study in this area. As we said that we in 2018 had to defer some major work items. So the first one that we're going to take on is unlicensed. It says here Wi-Fi and other systems operating in unlicensed bands. There's one work area in this sub-bullet that's of particularly high relevance because there's standards work going on within ASTM, subgroup F38, I believe is the right, yes, he's nodding. So there is work going on the remote ID standard. This is a high priority for this community because the FAA, in conjunction with law enforcement and Homeland Security, decided that they would not be permitting broad area relaxation of the current restrictions, for example, flight beyond visual line of sight. They would not be permitting that on a general basis until there is a solution to the remote ID problem. And that is something that law enforcement can rely on. So there's a lot of work going on standardizing remote ID right now. The proposal that's on the table actually runs in the unlicensed bands. And so there's a great deal of interest in having our TAC group look at that remote ID issue in addition to command and control over Wi-Fi, which is also of high interest. We are certainly interested in autonomy. There's overlap with the AI group here. As autonomous flight control and autonomous mission systems continue to evolve, that may actually make the spectrum crunch easier as you reduce the requirement for continuous high reliability data links between the ground and the air to assure both safety and mission success. So it certainly has an impact. And we'll go on as time permits with other aspects of our study. The other thing to note is that there is an ongoing multi-agency spectrum study related to the requirements of UAS and how those can best be supported by U.S. federal governments. The FCC is supporting that study, or I should say is part of it. It was actually tasked to the government under the Reauthorization Act for the FAA. It's called the Section 374 study. That study is officially due July 5th, which would not give us as a work group a chance to give much input, but at least the word on the street is that it's going to be somewhat delayed. So we're going to do what we can to give our input in to help the FCC's response to that. In particular, per the statute, that'll give us an opportunity and an incentive to look at some bands that are of high interest for UAV command and control that we haven't had a chance to look at before, specifically 960 to 1164 and 5030 to 5091. The 5 gigahertz band there is actually designated by the ITU for UAV use worldwide, and there's significant questions about what technical standards will be deployed in that band, and we'd like to help the FCC understand how to navigate through that set of open issues. Going on to this issue about aeronautical restrictions on terrestrial mobile licenses. So here, the question is whether some of these restrictions that have accumulated over previous decades remain necessary and relevant. Now, it's really the FCC's bailiwick, not our TAC committee's bailiwick, to actually answer the question. But we do believe that we can provide some input on how to assess the issues that are raised in this question of relaxing those restrictions. In particular, from what we're learning from our work on the RF analytics and from what we're learning from our analysis of UAV operations and spectrum requirements. Here I just listed again the the particular items from our 2018 recommendations that we're looking to provide further inputs to support. Informational topics, again, not a full sub-working group, but we do anticipate attempting to provide ongoing market updates and updates on what's going on in 3GPP. There's quite a bit of activity there, and it can be quite difficult for outsiders to track, but we have an ace in the hole. One of our members is deeply involved in that committee, and we'll be providing not a formal rapporteur function, but I believe we'll effectively have that same benefit from his participation in both bodies, and we're delighted for that. Thank you, Stephen. That brings us to the end of our short presentation. I do have a plant in the audience, you might say. I have a first comment that I'd like to give over to Stephen Hayes to make before we go into open questions, and then we'll take questions from everybody else. Thank you.
Thank you, John. I was recently at a conference called Connected Skies that was basically a meeting set up to bring experts together from the aeronautical, the drone, and the telecommunications community. And quite a few members from from John's working group were actually present there. And one thing, to some extent, the commercial drone industry has been a bit stalled lately. I mean, there've been lots of trials, there've been lots of videos produced with like Jetson-like, capabilities. Okay, I thought somebody was going to ask who the Jetsons were, but okay. But it really hasn't moved forward on the commercial front. So one of the questions was, what do we actually need to sort of get this ball rolling so we can actually have commercial rollout of these services? And with respect to the telecommunication industry, what we need to do, a couple of things came out. One, John already mentioned, which was for the remote ID, which is so important to security. What does it mean to rely on Wi-Fi and Bluetooth for these beaconing capabilities? Is that going to be sufficient? So it's very good that that will be analyzed. But the other is something that we haven't really looked at so far. The aeronautical community and the FAA is very much safety oriented. That's their goal, to keep both the skies and the ground underneath it safe. You don't want a drone falling on anybody. And so before any of these drone operations can go into commercial operation, they have to prove a safety case. And ultimately, if they have a command and control channel that requires no more than 2 minutes of outage due to some level of automation, or maybe continuous communication with the maximum latency of 100 milliseconds. If the systems they want to deploy have these requirements, they need to be able to prove to the FAA that the network they're using can really do that. And that requires data collection. And one problem is that the culture that exists in aviation is one of data sharing. But in the communication industry, if you go out to an operator and say, I want to know your network deployment, where your base stations are and what frequencies you're using, so I can prove that that my drone is safe over these over this flight plan, you get a different response. So I think one role that maybe the FCC could do is, and the TAC group could do, is look at this and see what could be done in terms of both what type of information needs to be collected. Is there any way to collect this without sort of giving away the family jewels? But until we can provide the FAA some sort of assurance that the communications really are safe, we aren't going to get anywhere, because their position right now is, okay, put some data where your PowerPoints are. So I think this is a good thing for the group to try to address, see if we can cover this.
Great, thank you, Stephen.
Question.
What, Adam?
Yeah, so when you look at UAVs, there seem to be sort of two very different issues. One is, what do you use for control, which tends not to be very bandwidth intensive? And then what is it that you actually use to move payloads of data around? Okay? And are you sort of looking at both of those? And is there is the same spectrum to be used for both purposes? Or is there really sort of an architecture of how you separate the control functions from the payload functions?
Well, I think from last year, there are 5, but John, you may want to...
I was going to say that. Yeah, the analysis breaks it down. Somebody's going to have to help me out if I forget all of them, but there's command and control. There is those payload functions.
Yeah.
There's also detect and avoid functions, and we had 2 others.
Identification.
ID, yep.
So,
Yeah,
and is there another one which would be, I have sensors on these things, which are in fact used for avoidance and things of that sort. They might need their own spectrum allocations also.
Yeah, so we certainly looked at that in the analysis, and when we do the broad analysis of Wi-Fi and other unlicensed standards we will be looking across all of those potential applications, which have different sets of requirements.
Yeah.
I think you raise an interesting point, and it's one of the ones that's being discussed with regard to the very precious spectrum at 5030 to 5091, which is, who gets to use it, who's required to use it, and what functions are you permitted to use it for. That because there's a very significant question about how much capacity that spectrum band will have for supporting very, very large UAVs that might be performing important functions like automated freight delivery and so on.
So you're looking beyond line of sight rules essentially, as opposed to...
Yeah, the work group is chartered to consider all of the classes of UAVs, including the big ones that might fly the kinds of missions that would today be flown by manned aircraft. Yeah. That's right.
Okay, and then out of curiosity, have you looked at what has happened in other countries in terms of UAV use?
Yes, that's one of the sources of data. We noted that there was great information coming from other places, and so we made the formal recommendation to the FCC last year that collecting data from those other countries would be an important part of any FCC action in the UAS space. So we have some of that data ourselves, but we have not made a formal effort to collect as much of it as possible that could be done, perhaps.
This is where I will reflect back on the earlier presentation from 5G and IoT. It was, in fact, Julie and I had a quick word on that it was really helpful to go country by country and sort of get a snapshot of what was going on. I don't know that's how easy it would be to have comparable kind of information, but it certainly was very attractive and significant contribution that was made by 5G and IoT group. So you might want to think about that.
We'll look at it. Great.
Just want to say there is an outfit called Zipline that does a UAV. You may have come across them.
Yes.
And they operate in several locations in Africa where you have no roads.
Right.
And they, do blood drops for blood banks, things of that sort. It's been running for years. Very effective service, essentially.
Yeah, well, since the last time we met, we had the first official delivery of just basically end consumer package delivery by a Chinese company in Australia. So that stuff is all moving forwards worldwide.
Great. Greg.
When I gave my presentation and mentioned down tilt, Marvin turned to me and said, "But what about the UAVs? Do you think that part of our examination should be variable tilt cells, so that if a UAV wants to talk to it, it can find it and talk to it?"
That could be very interesting. Certainly, we have heard one of the approaches being considered in industry is to deploy effectively a separate network, or at least a separate set of antennas that point skyward, maybe with less density than your ground antennas. So instead of trying to harvest your ground coverage, have dedicated coverage pointing upwards with a separate set of antennas. But your idea of dynamically creating the aerial coverage on demand, if anybody's pursuing that, we'd love to hear about it.
We'll ask.
That's the way all systems should be designed.
Kevin?
Yeah, so John, one area I didn't catch you mentioning, but maybe it falls in the category of payload, is the use of drones as cellular relay in maybe hard-to-cover areas of industrial sites, ports, things like that. Does that factor into the work that the work group's doing?
We haven't considered, I mean, we're very aware of it, and it's a use case that people have talked about, but we have not considered that as a major part of our work. It doesn't seem to change the spectrum requirements picture from the FCC perspective very dramatically, unless I'm missing something.
Yeah, for the control channels at least, yeah.
Okay. Carrie, I think
Sorry. So, quick question. I can imagine that there are different kinds of drones and UASs for different purposes or different use cases. Some are maybe more stationary in nature. If you think about, for example, disaster recovery, having a drone to put a base station up in the air for a little while, and then things that move around, carry payload and whatever. And I could imagine that all these drones have different requirements and maybe different regulations down the road. So is the working group looking at different use cases for drones and then maybe even coming up with some recommendations on how they should be looked at through a lens of regulation and requirements?
Yes, so far we have not considered those kinds of different use cases as potentially impacting our analysis. Seems like it could.
Okay. Adam, did you have another? No. Okay. Okay.
Michael.
Hey, thanks, Sean. I know that the most of the drone applications have been more of a cargoes and human payload. As time advances, I mean, recently at the Reagan Center, I think Uber had an actual display of the drone taxi. And I know there are a lot of other companies trying to offer some sort of air service from like Metro Center to airports and so forth, which involves the safety of life. And I wonder if the working group is planning, looking into some of the requirements, whether that will have any significant additional spectrum needs, since they deal with more of curricular safety issues.
Yeah. If the FCC wanted to specifically ask us to focus on that question, I'm sure we could look at it. Our bias has been to focus more on the things that are necessary for sustaining UAS market growth in the relatively near term. That use case seems to be a bit further out from our perspective. But be glad to have dialogue about that further if you wanted.
It's actually, I've just recently become aware of how fast that one is coming, so we may want to at least peek at it.
We also have a member of Boeing who still could not make it today, but I think that's Boeing has a little pet project, something like that as well. So
just a few.
I shouldn't say a pet project. They do have a project program working on that too. So.
Might need a new name though, right? It's not exactly unmanned any longer.
Yeah, exactly.
Unpiloted.
Yep. All right, I don't see any more cards up around the table. Are there any questions or comments on the airwaves? I'm not hearing any. So you get the record, I think, although it was fairly short at the first, but the shortest presentation today, but a lot of content. A lot of, as I would summarize the work done by all, you know, good start for the year, but there's a lot ahead of us. And the challenge, of course, is that this is a short year. To really scare you all, the 8th floor would like to have a look at what we conclude before our meeting, which is our last meeting, which is December the 4th, if I remember correctly. So somewhere around the middle of November, we will need to have conclusions and those wonderful actionable recommendations put into place, at least in draft form. So that's not very many months away. So lots and lots to do. As some of you point out, Adam probably the most, a lot of this year will be really preparing for next year, because the topic is sufficiently broad, and getting that funnel work down to the things that are more actionable will be a challenge. But we do have a lot to do here. We are going, it's embarrassing that we're actually going to end early. I mean, this just doesn't happen. We do, for those that are new, we do end on time, but ending early is. Yeah. I shouldn't encourage you. The 5G IoT group will take that as a license to go even further. Yeah. But I do want to conclude with how we opened. I'm really delighted with participation of our new members. This is great, and you've shown evidence of your heavy participation in this meeting, and hopefully you feel very welcome as part of the group. One of the things I will highlight, meeting before this one, the March meeting, we had a ceremonial 20th anniversary dinner the night before the event. Michael very nicely arranged for a very informal kind of meal last time, and it came off very well. I think for those that were in attendance, you enjoyed it. I certainly enjoyed it. So we will likely have an informal, nothing, must attend or what have you, but we will likely have dinners in the next couple of times as well. So if you can make your travel plans and they work out for you to be here in time to attend an early dinner, 6 o'clock or so, the evening before our September the 18th dinner, and subsequently the December the 4th dinner, then therefore the 3rd and the 17th, respectively. That would be something you want to at least put in the back of your minds. Just to really close things out from my end, I do want to pass along some special thanks. I've already indicated my thanks to our new members. We're just delighted to have you a part of it. Always want to recognize our chairs and of each, and co-chairs of each of the working groups, as there is additional efforts, and for Russ and for Brian in absentia, but still physically, but still very actively involved, and for John taking the reins on the advance and significant piece with Marty on even that working group. But thank you for your efforts. Thank you to the sub-working group level leaders as well, because we have moved to that stage. This is something, again, for the newer members of the team. At one time, this was a debating society, basically, 20 years ago. We'd come together and we'd talk about something, and at the end of the meeting, well, what should we talk about next quarter? And somebody would come up with something, and basically no work would occur in between, and we'd get together and we'd sort of debate that topic. It was fun, a lot of very good people involved, but not very productive, particularly for the FCC. And at this point, it's amazing how far we have evolved to an organization with chartered working groups that are chartered from the chairman. These are the chairman's activities, and not ones. I mean, we certainly, Michael and Julie and I, make recommendations, but often as not, they're changed. No, I don't want that one. Yes, I do need this one that you may not have ever thought about, and that's a good thing. That's a really good thing that there is that level of engagement by Chairman Pai and by others in the 8th floor. But it has also evolved in the dimension that we just talked about: working groups, sub-working groups, the subject matter experts. Over the course of the year, we will easily have 100 or even 200 people involved in one way or another with the TAC. And it does have an impact. Julie mentioned this. Ongoing activities, especially those that are future-oriented, as proceedings coming out of the TAC, often have their genesis into this body. And that, of course, is a significant reward by itself when you do something and make a recommendation and then have the FCC move forward on that recommendation, and it becomes law of the land, if you will, not really a regulation, not a law, but nonetheless the guiding direction upon which the nation runs, and as one of the, if not the leader of the world, one of the leaders, it then propagates around the globe, and hopefully for the betterment of the people of the planet, as Marty so appropriately pointed out. We do all of this not because it's great engineering and great fun for us exercising our technical capabilities. It's when we impact human lives that this is all rewarding. So, sorry for the philosophical bent, but it's we've got the time. So, as a well, the one worry, and you should be worried about this as a professor, my classes are 75 minutes in duration. So, in fact, I've been teaching in the law school, and they run for 3 hours. So, and we don't take breaks. So anyway, let's move to the close. I do want to extend the thanks beyond even the TAC members to those SMEs who've contributed, and many of them are on the line at this point, listening in. But then move to the liaisons that we have from the FCC. This is a really critical role to keep us focused and directed, and to serve as the conduit of information, sitting in on our sessions, bring the information right into the FCC, but both from the guidance side and from the delivery of the information that comes from this body into the FCC for its use. That's really an important role, and do appreciate the liaison so much. Always appreciate Julie and his guidance, and then absolutely critical is Michael with the role that he plays in really keeping us organized in all matters, great and small, and greatly appreciate your efforts. So with that, let me give you the final word.
Well, thanks everybody for all the commitments and serving the commission. I know it is a lot of challenge given your busy executive schedules, but we always appreciate your commitments, and it is also very challenging for us as well. Some of these topics are very interesting. Just to conclude, safe travel for everybody who has a long way to go, and hope to see everyone else next September meeting. So, thank you.
Hey, by the way, Dennis, can you queue up part 2 of the 5G IoT slides?
What? Part 2 of the 5G. Oh. Thank you, Russ.
Thank you.
Go ahead and start. Yeah, no.